to get to actual users to like sort of see what usage. So there'll be a lot of iterations, which I'll talk about later. But that's just one thing to note about like the AI native lifecycle. I already touched on this a bit, but as a PM, the way we write specs for like AI features is a bit different. So you have to be focused on the jobs to be done. You have to define things like what the personnel will be, the quality, the tone, and all of that, which I will still touch on. So I'm going to go into there. Okay. Again, I've talked about this a bit. So within the building and integrating stage, because this is a dev conference or like meetup, like I said, I'm not really, I'm not even a developer. So I'm not going into like the technical details of what to do, but I'm just sort of like trying to say these are some of like the challenges that comes up, right? Apart from like the actual like day-to-day code, right? So data is always one big headache when it comes to depending on the kind of AI feature, to be honest, right? But for a lot of them, data, because you can have the data, where's the data? It's always like a lot of headache. And then even sometimes after you build as well, when you store the data, the amount of data, the cost that is associated with that. So it's always like the headache. There's also a lot of things around like PII. So it's still related to data, but like what information can you send? If you have a chatbot and the user puts in their password or like their PIN, for example, how do you strip out that data and all of that, right? So that's another consideration you have to have. And latency, basically, which is also associated with cost, right? So that's one of the integration challenges. Okay, then the last thing I have around building and integration, because like I already said, I'm not going into like the technical details. And I think we've mentioned some of this, at least hallucination has come up with us, so we just don't skip it. But yeah, injection, I mean, we have that on regular like software, but that's something to note. But people are always trying to find, if you have an AI product, like people will try to find your prompt and break it. Like, so you just have to like guide against that, right? Hallucination as it is like AI hallucinates a lot. You can also have things like, memory leakage, leaking private information, which is also still tied to like injection, right? Costs. So when you have bugs in AI like features, right, it's more expensive because again, it's running on tokens and all of that. So you just have to like factor in the silent costs. Then sometimes your prompts, you wrote a prompt that's supposed to work one way, but then you are using a model and then they've changed something on the model and now you have a different output. And you may not even know immediately. Again, because the test case will say, is the output, is this working? And then it will pass. So there are other ways to like guide against that, but that's sort of like the major focus. Okay, so one big part of AI that I sort of want to like touch on today is trust, right? And we already talked about trust like slightly. But for trust, I really want to like just say, because you can't build AI without trust, and we need to like have that mindset as AI native software engineers. So I first want to like touch on what we call responsible AI principles. It varies like, but it's always at the end of the day in this bucket. So we have fairness. Bias is a big thing when it comes to AI, right? I think we've sort of heard that, like, if we are following like some of the tech news, or Gemini is splitting this out and all of that. So you just have to make sure that your whatever data you're using, or even if you're using a model, that it sort of like includes all of your is representative like of your own context, right? Obviously it has to be reliable, right? Especially because of how probabilistic AI can be. But one way to do that is just to have safe fallbacks. So if this and this and this doesn't happen, you have to make sure that your system has been designed in such a way that it can catch it. Privacy, oh God, privacy is like a big thing, especially when it comes to regulations. So if you're in Nigeria, we have NDPR. If you're in like fintech, you have CBN. There's always regulations and regulations. If you have a product that now serves the global audience, I won't say it's super, it gets complicated. EU is very big on GDPR. They have like different rules. If you get to US, some states have different rules. So regulation is a big thing because people are still trying to understand, the boundaries of AI and how to like, go about it, right? I always talk about like PII and protecting data, so I'm really going to that. Inclusiveness is also very important, right? Because you have different people like using your product. To be fair, this is not specific to AI. You should always like think of its inclusiveness, right? But it's sort of one of like the responsible AI principles. So if you are building something like, can everybody type? Those are some of the like chat, but can everybody type? Is there going to be a voice note option? Those are some of the things we should think about. Transparency too is very big. So transparency, explainability, how did, so I'm sure we would have seen it like typically when we use like any of the ChatGPT, Gemini, all of that, right? When they give you the answer, you would see like sources, reference, right? It's just to let you know how they got the information. So it's very, very important that you allow people like see how the AI generated their information. The other part of this is also the AI should be able to like, what I say, like let you know, like, okay, it's an AI. Like, and I think the reason why people put that a lot is because they don't want lawsuits, right? But you actually have to be very open. I mean, chatbot is an easy example because everybody sees it, but there are quite a number of other AI features. Some of them are very, very silent, right? So if you're building something like that, you have to be very transparent. Like, it's an AI, don't trust it 100% because it does make mistakes. So that's actually very important. If you are working in a company that has compliance, or you probably have like after few forms and sort of like say you've covered all of this. Even if you are not, even if you're a solo founder, it's still recommended to sort of have this mindset, even if you are just like by coding, because the person that will break it is outside. All right, then accountability, obviously. AI is still a system. Like someone has to sort of still manage it, right? So the next thing, because of how important trust is, I just want to like mention, I think I've covered some of that with the responsible AI, but some of the things that you need to consider when you are designing an AI feature, and see it as you are designing for trust. Okay, so because of like latency, you can obviously like, so I think there's always like a cost. So I had that challenge. There's always a cost. If you want, better, would I say if you want more, would I say better results or something, right? Then it becomes slower. So there's always like that balance of, should we improve the results, while there's bad UX. What I would say is that it depends. It depends on like the feature, it depends on the context and, the cost, but not necessarily like even cost of money. Like what's the cost of delay, for example? Is this something users want to like wait? Users wait like for 1 minute for autocompletes to come up? I don't think so. All right, so streaming, but I mean, there are ways the UI can sort of handle like that latency or like that delay, right? References, which I just talked about, they always have to be references. You always have to, like, that's why you rarely see any feature that doesn't tell you how it got its results. Feedback loop, very important. I'll talk about that in more detail, but you do have to ask for feedback. The very popular one you see is like the thumbs up and thumbs down everywhere, but there are also like implicit feedback signals that you should put in place. Persona, yes, AI does have a persona, right? So it's designed for, most times people are like, if you're building a product, you have to like sort of design or like define what exactly the persona of the product should be. Guide rails, I think someone has talked about guide rails earlier, but you do need to put guide rails in place, otherwise it's just to go away. Trade-offs, I already mentioned that there's always going to be trade-off, particularly when it comes to like cost, accuracy, speed. That's sort of like constant in the AI world. Okay, so the trust ladder, like, so aside just like, doing all of this background work, making sure that, okay, what you built out is, would I say, is compliant, you've done the trust, you've designed for trust, you've handled all the like all the edge cases and all the fallbacks, right? The nature of AI cannot, there's no way. I can tell you that for me, there's just no way you can fully test for it, right? So what I can, or like what I advise and what I've actually done, like we can minimize the risk, right? So minimizing the risk is that, how can we sort of like prevent this from, if something goes wrong, like how bad can it be? So obviously one is internal, right? If you're building, like you have to like just do dog fooding, alpha testing, whatever you want to call, but try to use it internally for a while, see the output, right? Use it as an actual user would use it, right? You can also, depending on like the type of feature, like, okay, you probably don't want the AI to like overwrite or just like do the solution, right? Again, I like, it's not just like chatbots. But an example here is a regular copilot. A copilot will sort of like tell you what's, then you have to like take the answer or like reject it. So that's like a fail, or would I say that's like a save, it's a save in between, right? And then you can eventually, maybe when you're confident and you feel like, okay, we are good, you can then get to the part where the AI, just like, like an agentic AI, is just sort of like doing whatever it wants to do on its end. Okay, so we've gotten to like the evolving part, right? Like I said, shipping is just the beginning. I'm actually serious. When you ship, like you just started the work. You've actually just started the work, right? The thing I've also like noticed just from my experience, like building AI products, is that by the time you think you are done, you just started. Because the edge cases, like those edge cases, like you'll be like 80% to 90% done. But you see that remaining 10% to like get it to maybe not perfect, to get it like production ready can actually like really take a lot of time. So I'll just talk about the things that help there, really. Okay, feedback loop. I spent like 2 years of my life working on feedback, seriously. But yeah, so the feedback loop is basically how do we get feedback from usage, right? To be able to tell if what we've implemented is working or not. And I just have a diagram here, like, the user's input, the model processes it, the outputs, we ask for feedback. So when you ask like the thumbs up or thumbs up and down that you see is like explicit feedback. So like the user has to click on it. And then you have implicit feedback where you're actually going to look at the user's actions. The reason why implicit feedback is still necessary is because, well, users don't give feedback. Like how many times do you click on the thumbs up and down button when you get like an AI output, right? So, it's actually very important that for every AI feature, every AI output, right, you sort of define mechanisms of how you can tell, if it was positive or not, or if it was useful. So you can look at what did the user do after. So if maybe like the system like gave an output afterwards, maybe the user did not give thumbs up and thumbs down, but did they copy it manually? Did you see that they used, maybe they went to that product page, so all of those things can help, right? But I think I have here like, you have to capture users' intent, add it to like your data set, right? Like the feedback because that's sort of how you use it to improve or evolve. Depending on what your feedback is telling you, you can then update your prompt, redesign your system, just see how to like adjust your system for it. And then you always have to do this. Like it's a continuous, it doesn't end. It doesn't end. Till today, like OpenAI and Google, they're still doing it. It doesn't end. Okay, so we've probably heard about this. It's one other thing about AI evaluation, right? But like I said, it's very difficult to test. Like, it's not like it's difficult to test. It's like if you do test, right, the test will pass. That's the issue. Like, it's going to pass. But it's not like a representation, right? So another way to like de-risk or like just test, aside like having like the feedback loop in production, is that one of the tests you can do is just evals, which has a PM, like I think even QA can do that as well. But you need to be able to like just say, what does a good answer look like, right? And then what is a bad answer? And then from there, you can evaluate it. So it's just like giving samples. Like I said, you can't 100% replicate how like users would use it like in the real world, but you can sort of simulate that, right? And then whenever you make changes to like your prompts, your system, you can always run it again to say, okay, is it good or not? So for example, so there are two things about that I wanted to mention about AI. About it can also be like intensive. It's still something I'm also like trying to like learn or get comfortable with. I think I'm in between the bad and the good, to be honest. Right. So the bad is just like, I'll just test it. Is it work? Okay, I think it's giving the response, right? But the ideal way to do it, or the good one, is to actually already have it pre-planned, pre-curated, quite a number, maybe 50 to 100, 150, 500, again, depending on how, the more, the better, right? But it's data, so you just need a good sample size. Then, the things that you'll be testing for is sort of like the tone, the output. If you gave us 3 variations, what was the variant of those 3 things, right? How fast was it? Are there prompts you struggled with? Are there things you can do? Do we need to add more boundaries to it? So like, that's sort of all the things we're doing around AI evals. But if you don't want to like really build a product that, I don't say we wouldn't have issues, because you always find bugs, but at least that, you've mitigated the risks of just things going awry in production. do whatever else at least to, even if it's the bad one or the in between, like I'm doing today, is better than nothing. All right, I'm a PM, so I have to like talk about success metrics, obviously. All right. So this ties into like what I started with, like the business is just going to, like they're going to ask you like, why should we do this? How would we make money? So some of those questions, right? So the things like you need to like just think about is when you finish like building, let's say you've launched, you're in that evolving stage, right? So that you're not part of like the 85% statistics. How do you know that this was successful? So you can do that in various ways. I mean, but some of the examples I have here, user adoption. Because sometimes, if you remember, we started with a problem, and it was an hypothesis. Somebody really knows these things. You are saying, okay, we think our users have this problem. Maybe you even do some research. But I can tell you that sometimes you do research and then the actual output, when you give it to those same set of users, will be very different, right? But if you made that hypothesis, you can then say, like, okay, with the way people are using it, can we say, you've truly solved the problem? So if the adoption basically just means that, people actually like using whatever you like percentage of, your users that are using it. Engagement metrics. The difference between adoption, I don't know if I'm trying to see, I feel like this, but let me just say, okay, so the difference between adoption and engagement is just, adoption is like, you've even used it, right? But engagement is more like, how frequently do they use, like if you've used it like the first time, like how frequently do they use it? Do they wake up every day, to always ask or like use this feature? Do they use it just once and then never go back to it again, right? Conversion, again, like I said, at the end of the day, the business is there to make money. Like there's no two ways about it, whether it is a bootstrap business, even if it is not profit, like even if they're not making money, they are there to get like whatever the value for the business is. So you want to like, because why are you building an AI feature? Like why are you trying to solve problems? Like you want to make sure that there's value at the end of the day. So there's value to the customers, but there's also like value to the business, right? So conversion is just like whatever drives the business. Is it like, is this feature converting? But if it's not converting, one thing I would say is like it's not bad to sunset. AI is very expensive. So if it's not working, you might need to like iterate, you might need to like change, into something else or just like shut it down and just know that it's not, maybe it's not in our own line of direction. CSAT as always, like just how satisfy the customers. Return on investment, I won't go into that because I feel like that's all I've been saying since. And this just is, so I think I wanted to just like, as much as you have like the business metrics or like the product metrics, there are also like technical metrics. Like after we are done, like, or you shipped, it's live. Things you also be considering is that technically, was it successful, right? So most times I've not worked on any AI products where we didn't do cost estimation beforehand. So you want to then check, is the cost, is it going AYR or is it still in control? Was the estimate actually really good that maybe we're even spending lesser, right? What sort of like the error rate, the latency, like, because we would have probably made assumptions based on this. So this is just like comparing what you have or, the assumptions you've made with what you have in production. And then I've gone through, but I won't go through this because I've gone through some of this already. Okay, I think I'm wrapping up now. Right. But the other thing that just comes up, I've talked about business case briefly, but the other thing that also comes up is like, is it worth it? Right. So is it worth it is sometimes it's not even just about the expense, it's also the cost of not building something else. Because as once you're like building one thing, there's only so much, no matter how many number of engineers you have in your company, right? There's only so much you can build at once. So once you start investing effort or time into this to take, and you also have to maintain. I think that's something some people forget. The cost of building a feature is not just building it, it's the maintenance of it. For every test script, now you now have to have those test cases there, right? If there's a bug, now to take attention away from like your normal sprint day to day. So it's like, is it worth it, right? And some of the ways you can already check is, what's the cost, right? AI, like I already said, has high OpEx, right? Which is like the operational expense. But it's possible that it will have like a high cost. But if we are saying that, oh, it's converting, the business is getting value from it, they can decide that, we keep it. Maybe it's, a competitive advantage, it makes us stand out, it makes us number one in our market. They can decide to keep it. Yeah, but the other part of it is also like, how do we price? I felt like my slide was very, very long. I didn't go into it. But I think that's sort of like the other. For internal tools, it's sort of like, okay, like I said, for internal tools, the only thing you just need to factor in is the fact that, well, if you were like spending like 5 million naira on the team, maybe AI would solve it, but it doesn't mean to get to zero. But you also have to remember that even for the AI features, you will still pay. So even if it's only AI 100%, the AI also has its own cost, right? But if it's for like a SaaS, you're trying to like sell software, you charge per month, charge per year, or you even have like custom B2B pricing. How do you charge? People have done this different ways. Subscription, add-ons, and things like that, right? But I think what's looking like the industry standard is either people are charging you per tokens if it's like a core AI native thing, or they're asking you to like pay extra for the AI or had it as an add-on. So that's sort of like basically what is there. But I'm just going to wrap up to say we're always building, and it's good. Like we love builders, I love builders. We need more builders, right? But let's try to take a pause and build less, right? Like the ones we build, let's give it some thought. Or before we start building, let's try to think more about it. Do we need to build this? Is it really important? What problems are we solving? We have a lot of AI tools already. I'm not saying they're enough, and I'm not saying that we can't even have like new ones. I'm just saying like let's think about it, but don't just slap AI on it so that you can say you are now an AI product, right? Validate more, like we always need to like validate. We always need to validate. Evaluate everything. Don't trust AI. I think we're gonna run that. And then embrace continuous iteration. AI products, development does not end. Once you launch, you just started. You have to keep going on and on. I think that is all I have for today. Thank you very much for listening to me. Do I have questions? All right.
Hi, everyone. Good afternoon. Hi, MC. Thank you so much for the presentation. I have two questions, right?
Okay.
And you answered one during the course of the presentation, but I feel there is still a bit of gap,
Okay.
before. So let me ask the first one, because I see PM, right, as a deep mediator between the designer. Oh, I'm a product designer, by the way, so most of my question will be geared towards that. So PMs, right, are more like a deep mediator between the designer and the developer or the engineers, right? Mm-hmm. So what are the ideal framework, that one needs to consider in co-creating with AI, right? Is it going to be in co-creating features of AI, right? Is it designer first, engineering first, or simultaneous prompting, just like you mentioned? And the second one, right, is, okay, let me ask it this way, because you answered one, which is the AI value features, right? In terms of AI value framework, where you mentioned user satisfaction, yeah. Now, the question is, what framework, right? What framework are PMs? Let me direct it now, because you are in between the designer and the engineering. So what framework, right, are you considering or putting in place to checkmate AI's decisions, or the outputs before they reach production? You mentioned when they reach production or after, right? But before they reach production. I don't know if that makes sense.
Yeah, it does. Thank you for your questions. All right, the first one around, should design engineering is, so I'm user first. I think it was even in my, which is why I don't fintech PM, AI PM. I'm just user first, right? So I'll say that, let's start with the user. Obviously, this is design, but this is PM, right? The reason why I involve engineering, at least at the leadership level, hell is, you know what the situation where you've done how it is, you've done 1 month of research, done the design, you're now, and I don't hand over to engineering. I don't believe in handing over to engineering. Eventually you hand over to engineering, but it's always better to involve them early. And they're also they are product mindset, right? I work with some engineers that the feedback they give actually shape the actual experience you're designing. So I would say it's the user first, which is primarily your work as a designer, as designers, but obviously as a PM, you also still attached to the users. So it's always design. That's always my recommendation. Start with the user first. It's just always good to still involve engineering early. Maybe not like at the stage where you've not even clarified the problem. But once you have the problem and you're getting to the proper discovery process, then just be one call. Let them just have an idea, right? And then when we start getting to like design and all of that, we can share it. So for the other one, I did cover it. Let me see. I think I'm out. But anyway, the AI evals I talked about should be before you ship. Right. So I covered it in two ways. Like the way I would answer your question is that how can you mitigate it is obviously like design with, that, and that was why I went through the design process, right? Like when you're designing, think of all of the considerations just to like make sure that when you go to production. So for example, even if things goes wrong with fallback, there's always grounded within the context, the AI will just, you already have a, let's say, percentage by which if the AI is not sure, don't give response, just tell us that we don't know it, right? But the most important one is the first one, like I said, is dog fooding. Like internal test or like have even beta, right? So just minimize, like I don't think you should build an AI product and just go like 100%, right? So maybe if it's a small company and you don't have like enough users, try to get some users to test it. Let it be very clear that it's just test, right? So I remember when I was building this slide, I was using Google Slides. I have like a Google, what do you call it? Google One subscription. I noticed that there's not an option to like generate slides, but it was in beta. I tried to use it and the thing was giving me very poor output. But it was very clear to me that it was in beta, so I can't complain, right? Then the AI eval part of it, it's actually like pre-production. You shouldn't, the essence of AI evaluation, it's sort of just it like as a test case, right? You're actually supposed to do it before you ship to production. So those students can help. But ultimately, it's those feedback signals you get in production that would help improve it. Thank you. All right. Okay. Oh, sorry. I'm trying to. Sorry, it's disconnected. Oh, okay.
Thank you. So my question, right, I don't know, is kind of similar to what you asked. So I just want to ask for your overview, right? We are more like advocating AI adoption in everything we are doing currently. And if you look at the market out there now, everybody is trying to build around open banking that is coming up. So from a perspective of a product manager, right, what do you think we should be expecting regarding AI adoption in open banking? Like, we should be expecting more fraud cases like data insecurity and all. That's just my question. Thank you.
Okay. Yeah. I think from that perspective, when you look at like open banking or how the adoption, I'll have touched on it, but let me just go into it, right? Like people always find ways to exploit, which is sort of why you need to be able to like like I want to even design like a user, like design like a bad actor, like someone that's trying to break your system. So I think it would evolve, but one is that obviously there'll be the positives. So you see people using AI to even like the fraud they say is actually to even detect fraud, right? It actually would help. So we have those cases, right? But we also have cases where, for example, people claiming they are who they are not, I mean, we've already seen cases where like people are like doctoring videos of someone that didn't do it, right? So my feedback to that is we have to tell, especially when it comes to like Nigeria, the market is still early. We are still trying to like understand. Not even globally, everybody's still trying to understand AI is. What is clear now is that there's now adoption. It's not like AI got popular like not like 2 years, but AI has always been there. Since I have started like my tech career, there's always been AI, right? But now we now have like that like ChatGPTs in billions, right? So we now have that mass adoption. So it's sort of like something that is still being watched, right? So time will tell, but ultimately, like design your own system to just prevent some of the things that might come up eventually. Thank you. All right, then. Thank you, everyone.
Can we give another big round of applause? Thank you. Thank you for that session. So, we are going to be having a panelist session, but before we do that, we're still expecting one of our panelists. So just something light, that's what I'll call it. something really, really light. So we're going to be having a short break, not break like you should go out. It's a short game session, very short. While we wait for one of our panelists to, once he comes in, we'll start. So it's very simple. The title of the game is called, I'm sure we are familiar with it. Sister, are you going out? Okay, I thought you wanted to escape when you heard games, but it's fine. Okay, so it's a charade game, very simple and short. Don't worry, I won't make it. So it's a short charade game, and I'll be needing volunteers. I won't like to call you, but if that's the last resort, I will call you. And if you look at me, I will call you. If you don't look at me, I said if you look at me. One sister just started pressing phone. I know you're not pressing anything. Someone started receiving a call from that end as well. Yeah, I know all those tricks. It works well. So I'll need a volunteer. It's just 2 teams. I will need a volunteer from this team. I'll need another volunteer from this team. I know nobody will come out, but if we mention something like $50 or $100, please, if you can sponsor it, is fine. I know we have lots of big boys and big girls here, which is fine. So please, I need a volunteer from here. Oh, we have one already. Let's give her a round of applause. What? You want to receive a call? Okay, I know that trick. It's fine. It works well. So let's have one person from here. So let me just explain the game. It's very simple. I'll call out a word, then you will act it out. So people on your team will guess that word. It's very simple. So I have different sessions for that, but I'm just going to do a movie. So we are doing a movie session, just 5 charade questions, then we go on. So let's have, let me have one person from here. One person, going, volunteer. Nobody. Sir, you want to? Oh, wow. You just coughed. So nobody is coming out. Let's start from here then. So can we have one person from here? Okay, thank you so much. The Lord has chosen. Let's give her a round of applause. Let's give her a big. Well, you have fans already. Do you know what can happen? After this, someone can just look at you and wire you $1,000. I've been in an event like that. Thank you. Let's give her a round of applause. Now we're going to have someone from here as well. So can we have someone from here? Going. Are you volunteer? You want to nominate him? Oh, sir. Someone nominate who? Which of them? 1, 2, 3. 1. Wow. Let's give him another round of applause. We have. Wow. Please come forward. Thank you. You have been chosen. You are the chosen one. Let's give him. Video him. Yeah, that man. Video him. All right, thank you. So it's very simple. It's a simple charade question. So like I said, I'm just doing just movies. So I will tell you a movie, you will act it out, and they will guess that movie. Yes, it's the name of a movie. Don't worry, it's not difficult. It's a name of a movie. I will tell you the movie. You will act it out to them. You cannot say anything. You cannot do. All you just need to do is use your body language to gesticulate or describe the movie. That's all. Do you understand? Please don't whisper. It's a game. I believe you understand the game. Yeah, it's very, very simple. Direct question. Yeah. We have enemies, beware. Okay, so let's have you in front. Let's have you. Please, let's give them another round of applause. They are volunteers. Okay, so the first thing you are acting is, I just gave her the name of a movie, so please act it out. Please act in a way that you will know in your heart that if someone acts like that to you, you will never get the movie. So, yes, the name of the movie. So I told her the name of a movie. She will act out the movie and you will guess it. It's very simple. She's what? That's the point. Okay, let's have you. A movie is a movie, so just act it. Someone said jagun jagun. How did you get that? Wait. The movie I told her was Mission Impossible. But from what she did, there's no way in 100 years I would have guessed that movie. Please do that thing again. What did you do? I don't understand. You want to jump higher than you are, but it's not. Is that what you did just now? Please, how did you guess the movie? I need to know.
Okay, so well, no, I actually guessed. Okay, I actually guessed because I was actually thinking of a scene, right, in my mind. So I've forgotten the one though. The what's it called? The exact movie, but I know that there was one scene where Tom Cruise was actually climbing a building. Okay, so I thought that was us show. Yeah. So like it was no, I think it's part 3. Yeah, I think it's part 3.
I have watched all the Mission Impossible in my life. There's nothing like that. Maybe you use AI or something. I don't know. Maybe because you are doing AI. But I should give them another one. I know. It won't run. Don't worry, I'm coming to you. Oh man. Spider-Man is easy now. Okay, so we're just doing one each. Don't disgrace your team, please. So the movie is. Don't say it. Don't worry. Triangle or. Don't give up. I know it will be difficult. You cannot talk. You cannot talk. You cannot talk. You cannot talk. Wow. But if this was a competition, I wouldn't give you. I would have changed your question. Do you know why? Because you spoke and you're not meant to talk. And don't let them frustrate you. But this thing you were in sister house. Don't let him work on your anger. Don't worry, calm down. But the thing you were doing too is like, I don't. It was like not your. But house is house. But I will give you another one because it's a technical cheating. Sorry about that.
But the guest is not impossible.
The guest. So they did the Mission Impossible. And so please, you cannot talk. But I will give you a very simple one. Very simple one. It's very simple. Bad. So let's give ourselves a big round of applause. Yes. It means you people. He went to find that sin of, I don't even know the sin now. I don't know the, or should we project it? Should we project the sin? No, the guy is sure waiting to talk. But don't worry, we agree with you. Let's just agree so we can move on. So thank you very much, everyone. So right about now, we'll be going straight to the panelist session. And we have great men in the house with loads of experience, and they will be debugging any question you want to ask. So please write your questions, write your codes. Questions, maybe even if it's a project at work, this is the best time to actually do it on a platter of good. Yeah, that is I'm saying your mind, right? Okay, don't worry. Even if it's a promotion exercise, it's fine. So our theme for this session is navigating engineering management in the age of vibe coding and AI assisted coding. And the first speaker I'm going to be bringing up on board is the engineering manager at Paystack. Please help me welcome Wari Owe. Please, let's give him a round of applause as it comes up. And also, my next panelist is the head of engineering at NigerPay. Ladies and gentlemen, please let's bring up Toby Adelaja. And finally, this is the group engineering manager at Givest. Please, with a warm round of applause, let's welcome Adio Aziz. And also to moderate this session, please let's also welcome Jola. Let's give her a big round of applause.
Hello, everyone. Happy to be here, honored to be seated amongst great men. I think we need another mic. Yes. So our topic for this session is navigating engineering management in the age of vibe coding and AI assisted coding. We'd like to do an exercise before we go right into it. It's just put your finger down exercise. So can we have like one hand up, 5 fingers up? Okay, our panelists would want you to join us. Yes. So the first question is, put a finger down if you've used GitHub Copilot, Cursor, or ChatGPT to write a code in the last week. One finger, put a finger down. In the last week. Okay, just one finger. Yeah. The next one is, put a finger down if you've accepted an AI suggestion without fully reading it first or understanding it. No, not in the last 1 week now, in your life. Okay, the next one. Put a finger down if you've ever argued with an AI because it gave you a wrong answer or nonsensical answer. Okay. The next one, do we still have 5 fingers up? Okay, we're being truthful. The next one, put your finger down if you've ever used AI to explain code that you originally wrote. Okay, sorry. The last one, put your finger down if you believe that using AI tool has made you a more effective engineer overall. Okay, so does anybody have all their fingers down? Does anybody have all their 5 fingers still up? So I think this is a very good place to start from, since we all use AI and we're all familiar with it. If you have all your 5 fingers up, it's either that you're living under a rock, you are lying to us, or your manager is sitting beside you. So we'll just go straight into the topic. I'll be asking Aziz, we'll start with you. Can you just briefly explain what vibe coding is and what AI assisted coding is, and if there's a difference between them?
I truly believe they are all the same because I think vibe coding is practically the evolution of software engineering. I think right now we are at the precipice of a technological evolution, and vibe coding is a way for you to even make yourself stronger as a software engineer. And I don't mean just you just giving it things to do for you. I think we are at the age of prompt engineering, where you can give AI some prompt and then you can get feedback from what you don't understand from that particular set of codes. But then vibe coding and prompt engineering, I think they are both the same. I think vibe coding is just a social terminology of actually really vibe coding. You are just, trying to make sense of or making your code, faster to build. But then I would advise anyone, if you're building anything, just make sure you understand it, and give it a lot more context. But vibe coding is practically it is the higher evolution of software engineering. Yeah.
Okay, thank you. Does anybody else have anything to add to?
In addition to that, I think different people define vibe coding in different ways, right? There are some people who feel like vibe coding and AI assisted coding are interchangeable, while some people feel like, vibe coding is being irresponsible with it and just taking whatever the AI has fed you, while authentic AI assisted coding is actually using your experience and your good judgment and your understanding of the system to actually vet whether the result is correct or not. But yeah, I think I prefer the first definition. I think when I define vibe coding, I use it interchangeably with AI-assisted coding, but that doesn't mean that you still need to be aware of the distinction between doing it responsibly and doing it irresponsibly. Yeah.
Do you have anything to add?
At least one thing is sure, you can't, and this is speaking to what you said about not necessarily knowing what you're doing. You can't truly vibe code if you do not know what output you want out of it. And it's almost impossible to actually build stuff through vibe coding without constant interaction and iteration. AI would most likely hallucinate and give you rubbish, right? You would have to join it, basically, I mean, it's basically AI assisted coding, right? I guess what I'm explaining is basically the same, except that vibe coding is what AI assisted coding enables, right? So basically you are iterating with the LLM, in trying to ensure that you arrive at a product requirement that you want it to build for you without having to touch a piece of code. But of course, debugging alongside. Yeah, so.
Thank you very much. I'd like to encourage us to put down our questions just so that we don't forget, because there will be a question and answer section as well. So this conversation will be divided into 3. there's the segment of vibe and AI assisted coding. Because our topic is navigating engineering management in the age of that. And then we'll have like practical management challenges that they might be going through. And then the last session will just be on leadership, culture, and then team dynamics. So under vibe and associated and AI assisted coding, we've already established what it is. Is this a threat or an evolution?
Okay, so I don't think the all would apply so much, right? Because it's both, it's a mix of both. If you've been following the news, you notice that OpenAI did release a communicate, I think today or late yesterday, that they were attacked, right? A phishing kind of attack that involved mixed panel, right? So, yes, it's definitely a threat because, in fact, I've had situations where I had to use ChatGPT, right? I was asking some questions, something around interviews, right? I was trying to like create interview questions, and I got responses that showed that ChatGPT knew some stuff about where I worked, internal information, right? Yes, you shouldn't be telling me about services that we're working on, right? But I got that information and I was shocked. So yes, it can be a threat in the sense that if it's not used fairly, right, within the context of policies set by the organization, you might be putting your company in trouble, or even yourself. People who feed LLMs with so much information, PIIs, the last speaker talked about personal identifiable information, a lot of things that ideally the LLM shouldn't have, right? And that in itself can pose a huge threat. The second one was whether it's a threat or an evolution. Yeah, it's also an evolution. Programming has come a long way, right? From the days of Ada Lovelace, right? And it has got to a point now where, and I want to say this because I feel like people are usually kind of shy to use AI publicly. In fact, back in the day when if you Googled something, how to reverse a string, how do you declare a variable in Java and stuff like that, people will laugh at you. But over time, we got used to it and we saw that we literally Google the smallest things we do every day. Some things we don't remember how to do, or we feel like we make mistakes around. And on Stack Overflow, you get the answer and then quickly copy it and update it, in a way that fits your code base, right? And I think the same way it happened with Google, it's happening with AI now. At that time, people would get, laughed at for using Google to do the littlest things. It's happening now, right? But obviously, we need to evolve with the evolution AI is bringing by actually embracing it and finding better ways to use it. So yes, it's definitely an evolution, and it's something that we all must embrace. Yeah, so.
Thank you. I would like to speak to him saying that now we use AI for different questions. So I was having a conversation with my boss at the office one day, and then he asked me for something, and I was going to go to the documentation of that package to look for it. He said, "You want to waste your time? Ask ChatGPT, we'll read the documentation for you and give you the response." So we are getting to that age where you don't really have to go to Google or open documentation. You can literally just ask and you get your response. So the next question will be to Toby. There's a lot of concern about how junior engineers will learn and grow if AI writes the boilerplate and handles common bugs. How do we mentor and cultivate talent in this new environment to prevent a co-pilot generation with knowledge gaps? Shall I go over the question again?
No, I think I get it. So I think it all comes down to mentorship, right? And when we're talking about mentoring junior engineers in this regard, the first thing we first need to accept that the vibe coding era is never going away, right? This is like I think Aziz said, we're on the precipice of something, huge, right? We're never going back. We're only going forward, right? And to your point, just like we talked about the whole Google, how people were laughing at you in previous generations when you use Google, and now is a lot more accepted. In the future, we're getting to a point where we're actually going to be laughing out. They will be laughing at people who actually don't code with AI. They're going to be looking at you like, what? So keep that in mind, I think we need to shift the way we mentor junior engineers and move away from skills that AI can now easily help you with and move into the more high level things like system design, things like communication, things like, the higher level things basically that AI cannot help you with, right? I think that in addition to that, we also need to acknowledge, just like you said, that even though you have this concern of AI, meaning making a lot of things easy and potentially making people lazy, there is also the potential for AI to become a fantastic learning partner, right? When some of us started learning how to code, when we started our development journey, if you wanted to learn something new, like you said, you had to go and read the docs, or you had to read a tutorial or watch a tutorial or something. If you are building something and you ran into an error, you probably had to ask somebody. If you didn't know anybody who knew the answer or had a fix, you probably go to some online forum, or maybe you go to Stack Overflow, right? And some of those solutions, the person giving you the solution might explain their rationale, might explain why it's the best solution. Sometimes they might not. Some of them, they think your question is too stupid. They even abuse yourself, But now we've entered an era where we can actually use AI as a learning partner, because these AI assistants and these AI models actually have access to vast amounts of existing data. They can actually pull all that data together and make it available for you in a format that you are more likely to learn from, especially because based on previous interactions with the AI, it probably has enough context on you to, who you are, what you do. Parts of that information might be important to you. And I can actually serve that information to you in a way that you best understand it. So I think we just need to acknowledge that as well and engineers, especially junior engineers, in the right direction.
Thank you very much. So just a key point is we don't need to be ashamed of using AI. Once it gives us a response, you can probe, you can ask more questions, because I've had an encounter with someone where he did something with AI, and then I'm like, okay, can I understand what is happening? And he couldn't defend it, but he did it. So I mean, you must do it and defend it as well. Yeah. So the next question: have you seen the dynamic between senior and junior engineers change? Is the role of the senior engineer shifting from a code reviewer to a prompt reviewer, an AI strategy guide? How has the code review process had to evolve? So it's like 3-1.
Yeah, I have a whole different perspective on that. So I think the roles will shift. An engineering manager will now be more of a solution architect. A mid-level engineer that just oversee things, or maybe a senior engineer. The roles will shift from context giving, crafting more prompts, and then a whole new set of skills will align, because in my opinion, I don't think junior engineers should use AI at the beginning, because there are a set of attributes they need to acquire. Things like communication, you don't acquire that, while using AI. because you need to talk to someone. You need to actually, you need to actually know how to, get information from people, those soft skills. And at the end of the day, fundamental knowledge stays, tools will come and go, so, but as they acquire those knowledge, that's when I feel that they can start using AI. And and when you start with using AI, those fundamental knowledge will not grow. So I feel the reason why most of us are using AI today is because we have that in-depth fundamental knowledge, So those fundamental knowledge are very, very important to the growth of a junior engineer. And I think an engineering manager's job will be is already way easier, because now you can, track engineers more. You can focus on the most important thing for things for engineering managers. You can, you can, you can manage well, you can track well, you can become a solution architect, like I said, and then you can now make people focus on thinking first. A lot of people just write. So now we are now evolving from a writing code, or just being very reactive, to age where you truly have to think. Yeah, you actually have to think, because like you said, there's AI hallucination. If you do not plan well. In fact, there's this new tool on Cursor. It's called agent mode, where you can get to plan well. You can plan, have a conversation with the LLM, for like 1 hour, like you are just chatting with an engineer. And then at the end of the day, you can give it an idea. Oh, you missed this edge case. Oh, you missed this. This is not the kind of architecture I actually want. Can we try this? You say, oh, I forgot. Okay, let's try it this way. And these are the things, in fact, when you are communicating with your, with your AI, then you are giving it more knowledge to who it's actually giving the answer to. It knows you. So it knows that, okay, when a new task is coming, it has domain knowledge of everything. So now it's more of, it's less of syntax and now more of domain knowledge. Yeah, thank you.
Thank you very much. It just brings me back to what the first speaker said, that we're moving from the code we write to the code that we actually design and the code that we collaborate on. Thank you very much. So we'll be going to the next segment, which is practical management challenges. Have you changed your interview strategy? Because candidates now can AI their way through coding assessments.
Yeah, actually, it has changed a lot. For me, I still encourage people to use AI for their interviews, but what I look out for now is just much different. Now I look out for core knowledge. I don't ask questions. I have conversations now, because if you truly have that knowledge, then you can chat about it. So I just, bring out things from different aspects, and if you actually understand fundamental knowledge, it means you can be opinionated about it. So I ask for opinion that, oh, what do you think about this? I may be wrong, but what do you think about it? So if you have a different opinion, it means you actually know that thing. Yeah, so it will, for me, it has shifted from, asking base question, what is this, what is that? But now I bring out scenarios, pick up scenarios, things that even if you are using AI, it'll be rough for the answers to come out. So we just, interviews now I truly believe it should shift from, the stiffness from, just have conversation with the engineer. Oh, what do you think about this? In fact, give them the answer. Give them the answer. Now say, okay, what do you think about this answer? When you have that core fundamental knowledge, it means you can chat about it. So it has changed for me. And now I look out for more core abilities in people, and then also, since a lot of technical things have been taken care of, now you now need to know ask about how they work, their, how they interact with other engineers. I think a lot of times, a lot of companies have focused on more technical abilities. Now you can look at a lot more things of the domain space. Yeah.
Thank you.
Thanks.
Toby, would you like to add to anything that he has said?
Yeah, I agree. I agree. It's really about moving away from those straightforward questions that test basically whether somebody can write code or whether somebody knows something specific within a specific language, and we need to move more towards scenario-based assessments, right? Scenario-based assessments, discussion-based assessments, where you actually get to evaluate somebody's abilities to problem solve and like design systems and communicate as well. So.
Okay. So how do you evaluate performance in a world where AI can boost outputs for mediocre engineers and magnify impact for good engineers?
Yeah, so it's still related, right? It's still related to, so in the previous question, we're talking about how do we vet candidates or engineers that are going to join the team.
Yeah.
There's going to need to be a similar shift in the way we assess engineers that are already in the team, right? So we don't want to be looking at quantitative things like, how much code are you writing? How much code are you pushing? How many PRs are you reviewing? etc, etc, etc. Now you want to start judging people based on more of those qualitative things, right? Again, how good are you at designing systems? How sound are the technical decisions that you make? And are you able to justify and communicate clearly the reasons why you're making those technical decisions, right? So I talk to engineers all the time, right? And sometimes when we're having these conversations, I might ask, why did you implement this like this? Why did you do this? And sometimes it's not because I don't know the answer. It's not because I don't even agree, with your opinion based on my own experience. But I'm trying to see whether you actually understand why you're doing it, and you're actually able to communicate that clearly to not just me, but other people on the team, right? And what I find is that some engineers are actually willing to do that, right? Some engineers are actually excited to explain the reason why they are doing certain things. And some others, are not, right? Either because they don't know how, which is fine, because you can train that, right? You can improve that. In some other scenarios, maybe the person just doesn't feel like, they don't feel like, or they feel like maybe it's an ego thing, like, I'm an expert in this field. Who are you to question my judgments, that kind of thing. But I always try to encourage engineers that, look, regardless of what level you are, right? Whether it's junior, mid-level, staff, whatever it is, you need to be able to justify and communicate clearly the reason why you are making these technical decisions. If we're not doing that, then I don't think we're doing software engineering. We're doing trial and error, So yeah, that's the way I think about it.
Yeah. Thank you. Valerie, would you like to add?
I don't repeat what is said, but I guess one other thing I look out for within the context of performance is an engineer's ability to be more opinionated, particularly around asking questions, right? I like people who challenge. So I literally don't have to be the one to ask the questions, right? What are the decisions you think need to be challenged? Are there questions you think need to be addressed such that whatever decisions we are making around tech spec you've designed, those decisions will be based on a consensus, right? As against just, because again, you could call engineers together into a design session and then they're listening to what you're saying and no one is saying anything else. And then at the end of 45 minutes, you're done and you're like, oh, hallelujah, let's all go home, right? But once I see that you constantly ask questions, you want to know why this is happening, it also means that you have leadership qualities and you're able to communicate, right? It means you are taking time to understand what others are doing, not just what you're doing, right? Because again, responsibility, ownership, very important cultural values you must have as an engineer, right? And I guess what this means ultimately is that we have gotten to a phase now where anyone can code. Yeah, anyone can code. Some weeks ago, in my church group, right, someone dropped a link. We needed a new timer in church. We didn't like the experience of the previous timer. And I looked at it. I just picked the link. I had used it before. So I went to Gemini, right? And I pasted on Gemini, can you come up with a plan on how to build this? I didn't need to write a prompt. It did that. I copied the entire prompt and pasted it in Kiro. Kiro is like Cursor, right? You know, of course I used Claude LLM itself. And it built the entire product, of course, with, you know, back and forths, right? So I had a working code base, backend, backend, front end, everything, plus a desktop application without having to write a single line of code. So essentially, I mean, I wouldn't need, and then we used it. And I built it in less than 2 hours, just from a WhatsApp conversation, right? So ultimately, it's now beyond your ability to write code. It's more about what you stand for culturally and the values, basically your culture, basically around how you work. Those are the things I probably would want to check.
I hope we're learning something. Yeah, I'm learning a lot as well. Reminds me of having a conversation with my colleague as well. He's a DevOps engineer, and he goes, I have plenty projects that Koso helps me write when I start to sell. And I'm like, you're a DevOps engineer. He doesn't do anything front end, back end, and he has them plenty. So you can imagine that we need soft skills to actually go far in this career that we are on. So we'll move to the next segment, which is leadership, culture, and then team dynamics. I'll start with you. What does a good AI usage policy for an engineering team look like? Is it about burning certain tools or about defining best practices for their use? And what are the key clauses?
I mean, you don't want to, the idea is not to stifle progress, right? However, it's important that fair usage is on the front burner whenever any tool is being used, especially if these are tools that require data to be crunched, right? So what does fair usage look like? Now, one of the policies is, it's obviously there's a cost implication too. Every engineer should be a little bit more responsible around how frequently they use AI, right? But that's just, you know, by the way. There's also the idea that you should be very careful on what kind of data to pass. You want to reduce, I mean, I work in an environment where, in a highly secured environment, right? You know, we hold card data and stuff like that. You can't begin to instant digits, for instance, you know, in the LLM, especially if it's not internal to you, right? Some companies are big enough to deploy their own model, but most can't, right? And so, yeah, one of the things is one policy is to ensure that you teach and train the team on the kind of data to pass to the LLM, enough not to at least create a loophole, basically, for attackers. And every time attacks, you know, happen, I don't want to talk about what we experience, but, you know, if you are on the back end, especially on the security side, you see that it's almost a daily thing that you get attacked, right? And now that there's this craze around AI, right? I think that's like the most important thing, you know, data privacy and ensuring that you don't put the wrong piece of data. Yeah.
I was in a gathering sometime last week, and the guy works in one of these big fours, and he said that internally they don't use AI, but to the world, if they go to pitch to somebody, to a business, they will add AI to the topic that they are. Meanwhile, they banned it because apparently one of their team members puts confidential information and it was. So, I mean, it's crazy. God will help all of us.
I think, sorry,
Yeah.
one other thing is how to efficiently use it, right? Because again, sometimes it doesn't serve you great purpose to chat in bits and pieces, right? You know, engineers should begin to, not just engineers, people who use AI should begin to learn how to get better at prompt engineering, right? Creating a proper plan for your work. Of course, making sure that your context window is not too large enough for the LLM to begin to hallucinate, because even when it's not large, it will hallucinate. so, but, you know, be more efficient, because AI is expensive, right? You know, OpenAI is looking for more money now. I think over $100 billion. And they're not breaking even in how many years? Yeah, because it costs a lot of money. So I think these are some of the things we take note of.
Thank you very much. So go to, I think
Can I
you can add.
add something there? Yeah, I think the thing I would add to that is also the need for standardization, right? Standardization around processes, especially around tooling as well. Of course, it's important for us to, as we move into the age of AI and we're kind of migrating our teams to more AI-based workflows, it's important for us to experiment with different tools and kind of assess their capabilities, right? And other considerations like data privacy, security, etc. But once we've gone through that stage of research and experimentation, there needs to kind of be consensus as to, okay, this is what we are deciding to use and this is why, right? And it doesn't mean that eventually that can change, right? If we can, new tools can come out and then we can decide based on new information that we want to add them, but there needs to be a process to that, and what we're using is to be standardized.
Would you like to add something else? No, okay.
They have said it all.
Okay then. Since the mic is with you, I would ask you the next question. How do you foster creativity and critical thinking when AI provides the first draft for everything?
Yeah. So the way to foster that is the first draft is not the perfect draft, obviously. So that's when you start exchanging ideas. You know, that's when you start talking about architecture. That's when you start talking about, you know, is it clean enough? Is it abstracted enough? You know, and then that's when you tell engineers to, you know, to come up with a whole new perspective, a whole new viewpoint. The first draft is just what you give it, and then you can now drill down. You know, what I do with my engineers is we have a planning session where we'll sit down with the AI and say, okay, these are the things we want to do. And then we go back and forth. It can be an hour or two. And then at the end of the day, you know, we have a big task planned out, you know, and then we can give it to AI to, you know, to spend, you know, a couple of hours to just do it in the background. So I think we are now shifting from a more syntax-based workflow to a more architectural solution-based workflow. So yeah, the first draft is not the perfect draft, but you can always, you know, at the end of the day, we are all iterating in perpetuity.
Thank you. Toby. The next question will be, do you think engineering teams will shrink, expand, or restructure in the next 5 years due to AI?
If I had to choose one, I'll probably say restructure, right? I think we've already kind of alluded to that in the conversation already. The way we work is going to change. The skills that are appreciated in engineers will also change as well. But I'm not one of those people who feels like, oh, AI is coming, engineers are not going to have jobs. What might happen is that engineers who refuse to adapt and adopt these AI tools and learn how to use it effectively and communicate well and vet the results that they get might become obsolete. But in general, I see it as more of a restructure than a shrink or an increase.
I think there's one thing that we've all come to agree today is that AI is not taking our jobs, but we will replace those that don't adopt AI. I think that's because in all the sessions that we've had before now, this keeps coming up and it's just very profound. Okay.
I think teams will be smaller, sharper, and more deadly, because you can get two engineers that know what they're doing to iterate faster, deploy faster. And I think roles will switch, because sometimes you sit down with engineers and then you try to say, okay, these are the things that we need to implement. And then you start checking syntax or how well it's built. We already know it to be well built. Now let's think about how, deployment would be. In fact, I think DevOps role will change. I think everyone would, it will help. I think it will just enhance everything, basically. Yeah.
Thank you. Where would you like to add anything?
I just feel like this will be based on the assumption that those in AI research will find cheaper ways for the models to run, right? Because GPUs are so expensive, or that these companies like NVIDIA and the rest would sell GPUs at maybe 10x less, right? Because if it continues the way it's currently going, I do not think we'll be able to afford AI in the nearest future, right? So we're saying all these based on that assumption, right? Because if it doesn't work over the next 5 years, then I do not think we'll get to a point where AI would define how things will work, right? So all things being equal, yes, I do agree.
Okay.
I think I agree with you, and I think one thing that needs to change is we might need to move away from the token-based system, and then I think the technology of compression needs to improve in the next 2 years.
Yeah. Okay. So I have another question, but everybody would answer this. There are actually two. You would just basically tell us how your day-to-day is, if it has changed. Are you spending more time on coaching new skills, designing new processes, managing the cultural resistance of these tools? And then you would share an experience where you've used AI and it went wrong. So we can start with you.
Yeah. I'll say my day-to-day has definitely changed. Of course, because AI is able to help with so much now, it means that I've been able to shift a lot more from being operational to kind of focusing on the more, would you say, soft skills of engineering management. So relationship building, leadership, all those kind of things, right? Because AI helps a lot with, like documentation, right? It increases your efficiency with bringing up documentation. Also, processes, right? Kind of streamlining the processes as well for the team. So I've seen my day-to-day actually shift in that regard, definitely. What was the second question?
An experience where you used AI and it went wrong.
Oh, okay, yeah, definitely. So not too long ago, I was trying to. There was a project, that I had to work on, and I was considering using a different technology than I am used to or that I'm familiar with, right? And I was trying to do some experiments, test some assumptions, and I just thought, you know what, I can use AI now, no wahala, and I embarked on that journey, and it got to a point where I hit some challenges. I got to a point where I hit some errors basically, and I wasn't getting the right results, and because I was not steeped in that, in that technology, it became a situation of kind of banging my head against the wall, right? That's why I'm sure a lot of people have had this scenario where, you're working with an AI and maybe it's giving you a result and the result is not okay, right? But because you're not steeped in that technology, you cannot adequately correct it, right? And it gets to a point where you're kind of just banging your head against the wall. The AI will even whine yourself. Like you correct the AI will tell you, wonderful suggestion, Toby. That's why you're the head of engineering. And it will still give you rubbish again, So yeah, so it still all boils down to that relationship between how much experience, how much judgment you can bring to actually working with the AI. The relationship is like an inverse relation. Let's call it an inverse relationship, right? So the more problems that you have are inversely proportional to the amount of judgment and the amount of experience and the amount of understanding that you can bring to it. The more that is, the less your problems will be. The less it is, then the more problems that you run into. Yeah.
Thank you very much.
Well, first, it has definitely increased my efficiency. However, I've had more problems to solve, right? I think that's one thing AI will introduce. Because ideally, we would expect that because velocity will increase, your efficiency will increase, that ultimately there'll be less work to do. But unfortunately, I've come to realize that the AI craze has actually created even more problems, right? PMs now dream, right? Then come back from their dreams and tell you they want you to do something, right? So I think that's, so basically one, more problems, but of course, because AI increases your efficiency, it has helped me to do a lot more. Toby talked about documentation. I embarked on I wanted to write a ROM book recently, because again, the improvement of processes is one thing AI would definitely help with. Automations, building new workflows, and we heavily leverage AI for that, right? And I hit a snag at some point and asked myself, why am I stressing myself? I just fed AI with the necessary information and generated the ROM book, and then I just looked at it, made some updates, and that was it. Clean, and straight to the point, right? That ideally would have taken me days, to do, but with AI, I was able to pretty much do it in a very short while. Plus, we have bots now that could literally go into the database and crunch data, right? It will return the results to you, but it will return queries that will allow you, to fetch the exact data you need, right? That's quite interesting, right? So these are some of the things. And, I guess one other thing that would become so important, I mean, it's important now, is data analysis, getting to understand data better, getting to visualize data even in a better way, right? With the AI craze now that we're experiencing, more people will begin to understand the importance of data and how well to use data to make new decisions. Because I actually have noticed that in this part of the world, first, we have a lot of fake data, especially the ones that come from the government. If you get data from the government, between me and you, don't tell anyone, it's mostly fake, right? Or at least it's insufficient, right? So basically, you'd probably have to make assumptions based on that data or find ways to create your own, right? But thank God for the startup culture, the startup environment. We've been able to create a lot more data, enough for us to be, to make important decisions within the space, right? So I think AI has helped me to better understand data, because my work requires that I do a lot of that, right? It has definitely done that for me. I guess that's basically what I've benefited, from AI. But definitely, I've come to realize that I've had more problems, to solve and more sleepless nights. Yeah.
Okay, your experience where it went out.
I did talk about one on the run books, for instance,
Okay.
where I pretty much, hit a snag, right?
Fair enough.
And not just the run book itself. Before I created the run book, the tool I was trying to work on, I also hit a snag with the templating engine it uses. For weeks I was, obviously it wasn't like as if I was on it for weeks, but I picked it up, hit a snag, dropped it, and went about other stuff. And then when I went back to it, it occurred to me that, man, I needed to get this done. And, I was able to do it with ChatGPT in this case, right? So Grafana specifically. Yeah.
Nice. I think from what you said, you shot some people stray bullets in the PMs, but I think product designers are a lot more dreamers than product managers.
And the funny thing is, yes, I know, I agree that product designers are dreamers, but I think AI tool does help PMs. I mean, one of the PMs I work with basically uses AI to build clear prototypes and user experiences based on what the product designer has said, right? So he would literally just, I think he uses both or something, right? And easily in few hours, he has come up with the exact design based on the conversation, based on the designs the product designer has brought forth, and present to the team, and is able to show the entire experience, based on what he did, and all this because AI.
AI is coming to be. Thank you very much. Aziz would like to have you.
AI has pretty much optimized my workflow. In fact, has automated some part of my workflow because, as an engineering manager, you need to touch grass with humans. You need to be able to interact with people because you are doing technology and people. So a lot of engineering managers, our work be narrow based sometimes, and when you go down into that deep hole, you won't be able to go broadly. So what it has helped me to do is it has helped me, think broadly on all the products we have, and yeah, that sometimes Question was
Where it has gone wrong.
oh, I think that was the early stages of AI, still trying to adopt it. You know, a lot of hallucination that okay, this doesn't work. You know, so for me, it has helped me a lot. In fact, I think I've 10x my workflow. I think I've even become a better engineer. Yeah, I think I've become a better engineer because you need to ask yourself what do I want to achieve? What's the end goal? What my problems are and how it can help me work efficiently. So I think, yeah, I think AI is very much contextual. You know, you should use it to your own context. You know, where identify what your problems are from. AI cannot identify that for you. You know, yeah. But at the end of the day, in retrospect, I truly believe AI is AI is a technological leap for us, a big leap for us. You know, and I think we're in a very, very lucky generation right now that we are using it to, to optimize our workflow. Yeah, thanks.
Thank you very much. So with this, we come to the question and answer segment of this. Please let's put our hands together for our speakers. I mean, it has been very insightful for me. So if you have any question, anybody with question. Okay. I think we can just write it down and then pass the paper because of our mic limitation. So please, can you write your questions down and then, or you can talk if you're allowed. Yeah. Or we can start with you. Yeah. You can just stand up and ask your question.
Right. So I think most AI code relies on a lot of dependency and libraries for components and features that can be written natively, which makes the code less dependable. How do we strike the balance between writing code with AI and core engineering principles that is grounded on principles like cohesion and coupling? So let me give an example now, like a front-end engineer, right? So there are some times that you would give some prompt on maybe AI is like lovable and the likes like that. What they do is that they would, instead of writing, let me say I want to write an input button that you have to build, they will use components like, let me say, ShatCN and the likes to build those components for you and you just use them. So like, how do we now strike a balance between codes that have a lot of dependency, because you don't know what might happen tomorrow. Those dependencies, they may be discontinued, they may be just like that, and it's going to affect your code base overall. So how do we manage that? Like, how do we strike the balance between writing native code and codes that are being generated by AI? So that's one. And the second one, what is the major concern of using AI for finance and banking and related services? And why are traditional banks opposed to the use of AI, but open banks advocate its use, like its uses in services such as spending insight, fraud detection? Do they use LLMs? And if they use LLMs, how do you like abstract and encapsulate what the model sees and what the model does not see? Like if those open banking, like let me say PiggyVest and Paystack and Drex use AI, like how do they abstract and encapsulate what the model sees and what the model does not see? And I think the scenarios for using AI. Okay, just let me answer. Okay, the first one, like, how can we strike a balance in the codes that AI generates and the core engineering principles of cohesion and encapsulation in those dependency codes?
I guess I can go first. First of all, I usually don't advise. Okay, one, I don't know if it's a fact. One thing I've established is that the best the LLMs can do is what a mid-level engineer would do, right? I have not, like, I've yet to see an LLM, at least code generated by AI, that's senior level, right? So with this in mind, I don't expect a serious engineer to leverage AI entirely when building, right? It is meant to be a tool that enables your work, right? It's meant to be a tool that helps you build or increase efficiency, right? So, for instance, you want to write queries to, you want to update the database and you have some really complex queries, right? Beyond just running the explain command in MySQL, you can actually have AI help out with that. You have snippets of code you want AI to work on, something around encryption, tests, for instance, unit tests, couple of integration tests, generating specs, interfaces. Those are things that you don't need to stress yourself around. Oh, you have a tech spec and you want the models to be generated. Why do you have to start writing classes when your tech spec already clearly states what you want to deliver, the various data points? Yes, you can use AI, right? In fact, one of the things I tell my engineers, I don't see a reason why you are handwriting unit tests, right? Now, with that in mind, I remember saying once that you must also have a clear plan. Now, beyond the plan, when writing code, you should learn to keep a config. Sometimes these LLMs ignore the configs, but learn to keep a config that serves as a check for the LLM, such that it doesn't go about using libraries that it's not even supposed to use, right? Because some codes are very strict. There's some code bases that are very strict, and you have to use the internal libraries, right? So when you keep such configs, for instance, you help the LLM ensure that it does not go beyond the boundaries that have been set already. So it's a lot easier to strike a balance when you know what you're doing, which is why, I mean, I would go back to what Aziz said, that he doesn't advise that junior engineers use it so much in writing code, because ideally, no dumb person should be using AI to write code, right? It's not for dumb people. It's for people who already know what they're doing, right? Like I said, it is meant to enable your work, right? So yeah, I guess I have explained some of the use cases where AI would help, right? I mean, if you're doing a hobby project, that's fine. But if it's a serious project like Piggy Vest, may my money not go lost. So I don't expect that you would. I mean, I wouldn't give you a task and you just feed it into AI and then return it. Most likely, what Aziz still said again, your PR might get closed because obviously we'll start taking note of certain things. So yeah, don't be lazy, right? Just leverage it to improve your efficiency, but do not depend on it to do your work for you, and then set clear boundaries for the LLM itself by using configs and plans, basically.
Okay. You can come forward.
All right. Hi, good afternoon, everyone. My name is Wale. So my question, the main limitation to AI today is a cost implication, like mentioned also, Wari. And I know that I don't think it's up to 2 years when we are deving, right? Deving that you can just feed a context to, you write the code, this is the PR for you, right? And then the cost limitation we are talking about is mainly coming from the use of GPUs, right? How expensive they are. Now we have TPUs from Google, which is extremely cheaper, right? So what do you think the future looks like? not even distant future, in the next 2 years for, should I say, AI assisted coding?
Okay, so first, we are moving away from simply like the term AI assisted coding to agentic coding now, right? Where you have less hallucinations, you can create personas, and you can have several agents communicating with themselves based on your initial prompts, right? So do this, this, and this. And you find agents arguing with themselves, and you're seeing the arguments, you understand, and then trying to improve the work by themselves. One agent is saying, there's an error in what you ideally would have done, right? So, and to make that happen, it requires a lot of compute power, right? Yes, I see what Google is doing with TPUs, and it does sound noble. But to be honest with you, if the EU and the US does not come to, because again, there's another battle with China, right? If there's no global, okay, well, I can imagine that China would want to really, really improve the AI space from the hardware perspective. But if there is no clear policy around ultimately making it cheap for the entire world, we might experience a crash. But I do not see that happening. Why? Because, AI is a huge money spinner. The companies might not be breaking even, but the engineers are making money. The investors are also like making some money on the background in the way they can, right? And some of these companies are also enabled by the governments themselves. So it still requires, to a large extent, government policies, tax breaks, access to minerals, for instance, that make for easy production of this equipment and stuff like that. You see the insurgency in several countries in Africa. Some of the minerals are used to produce, not just weapons, but even GPUs themselves, right? So government still has a huge responsibility to play in the future of AI, essentially.
Thank you.
Thank you. Question before I give the mic to somebody else. It says most of the LLMs do not have African content. What are we doing to improve that? Most of the LLMs do not have African content. What are we doing to improve that?
It sounds like where's the person that's what's the person doing to improve it? I think it has to be a combined effort, right? It's not can't be any one person or any one person's responsibility. It has to be, and it's not even just industries. It has to be a combination of the private sector and the public sector coming together, right? To find creative solutions to these types of problems, right? So yeah, that's basically it. I would say it's not what are you doing now? It's something that we all kind of collectively need to look at and come together and solve. Yep.
Hi guys. So I think my question is around security. So, I think you guys are talking about how you guys developers shouldn't give too much context to AI and what's going on, obviously, in what you're building and things. So I think my question is, how much information is too much information? Because if you're coding or vibe coding with AI or even working, not even engineers, let's say like, even the QA people or the PMs and things like that, you have to give AI context into what you're building so that it can give you a correct answer. So I think what I'm asking is, so how much information is too much information to give AI? And, what shouldn't you give AI as information? Because, as you mentioned something like, you even do, is it like PRs or something with AI and things like that, and everything's linked to Slack and stuff. So obviously AI has access to your Slack, your messages and things like that. So he has a lot of context to what you're building. So that's my question. So how much information is too much information? And obviously AI has more access to things that you don't even know it has. Like he mentioned that, AI had stuff about your information or about your company. So yeah, so how much is too much information?
Thank you. So there's something I do right now in PiggyVest. It's AI governance. And AI governance is we have a set of rules that guides what AI has access to, and also giving AI access to the organizational context, be it products, be it HR, be it technology. And I don't think it's the matter of, is it too much information? I think is the question of, is this information secure? Is it going to open a security loophole in your company's system? Is it going to is it going to cause harm or future, harm to the company? And I think you should give AI more context to what you do so that you can execute your work better. And I think the most important thing at the end of the day is AI governance. You need to be able to govern your AI properly so that it won't, open vulnerabilities in your system. And I feel like I think that everyone should, in this age we are in, everyone should take one or two courses on AI governance, whereby the product people can even work efficiently. Right now, I think by this time next year, product people will be opening PRs. Product people will be opening PRs, and this will be it will be in conjunction with engineers, everyone synergizing together to to plan the week ahead. Having now I think on Mondays everyone is always on stand-ups. Now these stand-ups will now be, okay, these are the things we want to do. How can we plan for this AI to actually build this thing? So AI can finish a week work in probably a day. With that is with the proper planning part. But then, like I buttressed the other time, we need to be able to put guardrails on this thing so that the governance will be so much contextual to the organization we are working with, without opening vulnerabilities in our system. Yeah.
Yeah, thank you very much. Unfortunately, we can't take any more questions because our time is up. But I hope that you really learned a lot from this session. Please, let's appreciate our panelists once more. Thank you very much. We can close these assets.
Thank you very much for that session. Please don't be in a hurry. Don't go away. We still have 2 more sessions to go, and we'll be done in any time soon. Shortly, we'll be out of here. Please, we still have 2 quick sessions to go. So we'll be taking a quick 5-minute break, and we'll continue in just 5 minutes so we can stretch. Please don't go away. Please don't go away. Please, thank you. 5 minutes, we'll continue with the next session. Please don't go.
in English and flow formatted with proper spacing, file paths, and function names. Everything I
feel like I dream. Although you stand by world is rolling. But some people want that. Now without me, I don't know. You feel it. But where the life, time is better. Let you the so now no more than no top and proper. Some better got some action. I know but you see, if you are not true, follow you and study fire. Me, who will believe you? The world is calling me liar, liar. Now me, I don't know. Those guys, I don't want for you, but it's you. I just see in my put on the oh baby, I'm not fighting. I'm not before.
This is your brain when you're struggling to focus. And this is your brain. You're in the zone. But getting in the zone and staying there, that feels like luck and something you can control. So that's why we made Brain FM. It's like a do not setting for your mind. that gets you focused in just 5 minutes. Using science and sound, BrainFM guides your brainwaves into an optimal state for productivity called neural phase locking, which lets different parts of your brain work together more easily. Actually increases and sustains your focus over time. You stay in the zone for
session.
You can also use BrainFM for relaxation, meditation, even sleep. But don't take our words.
Can we come together? We are starting the next session.
And see what BrainFM.
Can we sit everyone? Please. Hello, can we sit down?
Really take off. Website, live, level stuff, and plus extra services and tools, and 24/7 customers. All it things keep stacking.
Starting the next session immediately. Can we sit?
Girl, vibe, make you feel like a fool, baby, oh my, no doubt. Biggie never let
Still waiting for us to settle down so we can start. We're still waiting for us to settle down so we can start. Please. All right, so the next session is understanding MCP. And this session is going to be facilitated by Ayodeji Abodori. Ayodeji Abodori is a seasoned software engineer with over 8 years of experience building scalable enterprise-level systems across fintech, banking, and global tech. He currently leads banking and payment engineering at NigerPay, where he designs and manages mission-critical financial services used daily by consumers and businesses. His past experience includes engineering core financial infrastructure at Africa Fintech Limited, UK, and delivering major enterprise solutions at Wema Bank, such as the debit card auto-renewal platform and an enterprise-wide feedback system. As a founder and consultant, he has also developed impactful timesheet subscription and business application for clients in Nigeria and the UK. Ayodeji holds a master's degree in information technology from the University of Lagos and a bachelor's degree in computer science. He's known for his passion for clean architecture, system design, and building technology that solves real-world problems at scale. Ladies and gentlemen, please, with a round of applause, let's welcome Abodori Ayodeji for his session. Thank you.
Hello, everyone. Thank you. Hi, everyone. Hope everyone is doing okay. And I hope you're not tired already. You are. Okay, just bear with us in an hour. Not just me, right? So we have 2 sessions, my session and the final session. What an interesting profile that the guy read. But I see myself as a software engineer or a solution architect. Software engineer, solution architect, building solutions, scalable solutions that users use. Today, we're going to be talking about understanding MCP, the framework, or you can call it the protocol, that powers the next wave of AI applications. So can you help me with that? These are a couple of things that we're going to be talking about today. We're going to talk about the problem. Why did MCP come into play? What exactly is the problem that MCP is trying to solve? We're going to talk about the model context protocol, which is MCP. We're going to talk about the components of MCP. We're going to talk about the communication flow. We're going to talk about using an MCP server. And if time permits us, we're going to build an MCP server. And finally, we're going to take a look at MCP Inspector. Okay, that's not moving. The problem. I know we've heard about LLMs and that's what we're talking about all day, but I would like to further explain it in a way that should, in case you did not understand it earlier, you can understand it now. LLM, which is called Large Language Model, is an AI system that is trained on massive amounts of data to recognize patterns in language and generate outputs based on these patterns. So how LLM works, and a lot of us, we've used LLMs, we've used ChatGPT, which is an example of LLM. You feed it data, it processes the data, and then it returns a response back to you. The thing about LLM is that it's only able to produce data based on what it has been trained on. Whatever you train it with, it can produce data based on that. I have an analogy here. Imagine someone who is a story writer, a seasoned storyteller, who has read lots of books, and you approach the storyteller and give the storyteller a couple of words for the storyteller to come up with a story based on those words. And an example I have here is, once upon a time, when you hand that text to the storyteller doesn't need to think back to the books that it has read or he or she has read. The storyteller just tells you, oh, once upon a time, and that person can cook up stories based on the information that they have. Another example, someone who is a seasoned musician. If you come up to that person and say, oh, based on these few sentences, and you come up with a song, the person doesn't need to think of all the songs that they've learned in the past or look at a lyrics. They just come up with a song based on the sentence that you've given them. That's how LLM works. LLM doesn't look at what it has been trained with. It generates text based on what you give to it. Whatever you give to it, based on the patterns of the text that you've given to it, it's going to generate text to fit in that pattern. Now, I have this analogy showing this storyteller boxed up. The storyteller can only give you information based on what it knows. So if you ask it something beyond the information that he or she knows, being a storyteller, it can cook up something like all the science fiction, cook up something just to respond to you. And that thing may not make sense, but because it's a storyteller, I can always come up with something. That's how LLM behave. If you ask them something, if you ask LLM information that it doesn't know about, rather than say, I don't know, well, some of them say they don't know, right? But some LLMs cook up content because that's all they know how to do anyway, to cook up content. And oftentimes the content may not make sense. The other day I was writing, I had an assignment to submit while doing my master's, and I had fed the LLM some data and I told it to generate a report based on that input. And it got to a point, it started referencing different books outside of what I had given it. By the time I checked, I realized that those authors, those books did not even exist anywhere. So that is what we call hallucination, where LLM, if they don't have the content, they cook up something just to give you, right? And if you're not careful, you may take that as a valid source and, God help you submit it as your thesis, you're going to fail. So LLMs, the information an LLM provides is restricted to its training data. Since all that LLM does is to generate text, it still generates an output, though incorrect. Now with this, AI applications, the AI engineers, they realized that they needed to bridge that gap. They have this LLM, this massive brain that knows a lot of things that they've trained with so much information, but this LLM is unable to help them in their day-to-day. Right. So in order to bridge that gap, they decided to build tools to help the LLM make use of those tools. For example, here, I have a large brain which represents the LLM, and we have a line connecting it to different tools. Integrating AI application with external tools, external data sources and tools furnishes large language model with the necessary context. So in order for the LLM to stop hallucinating or to tell you it doesn't know what to do, AI engineers then decides to integrate LLMs with tools. Because think about it, you have this powerful brain and it's able to help you solve certain issues that you have. Now, what is the point of the powerful brain? So here we see AI engineers building different connecting tools in order to help them, in order to empower the LLM or give the LLM enough context to support their business. Now with that, so here we have LLMs being connected to tools, but even if that solved the hallucination problem, even if that enabled AI engineers or developers to make progress in their task, there are a couple of problems that came up with that. Number one is the MXN integration. Nightmare. MXN integration. M means model, N means tools. MXN. Now, the challenge that came with MXN integration is that if I have one LLM or one AI model, and I want to connect that AI model to, let's say, 50 tools, it means that I'm going to have to build 50 custom tools to support that integration. That's MXN. One LLM or AI model times 50 tools. Now imagine I have 10 AI models, and those 10 AI models also need to connect to same 50 tools. Then we have 10 times 50, which is 500 custom integration. Now just think about it. It is not scalable, right? So that led to MXN integration nightmare. Another challenge with directly connecting LLMs to the different tools is a change in the provider's documentation would warrant a change in the implementation. Different providers, let's say you have Slack, or you have a weather API, or you have a bank API. If they change their implementation, because there's a tight coupling between the LLM and the tools, you would need to make modifications to it. And it's a hassle because with the example I gave, 10 AI applications, 50 tools, if one tool should change, that means you have to change it in those 10, on those 10 different integrations. So it's a nightmare. There's also the challenge of vector locking and fragmentation. Each vendor built their own custom SDKs to support this. So it wasn't scalable, right? You have to learn, okay, how does OpenAI support connected to database? How does Anthropic Claude support connected to database? How does Gemini support connected to database? So you have to learn all of those different vendor-specific integration, which wasn't scalable. So these are the challenges. And lastly, context window inefficiency. Imagine a situation where you always have to copy code from one section to the LLM, or you have to copy your books, just to feed it. It's a whole lot of nightmare. Now we have the model context protocol. Now with the invention of MCP, we get to solve a number of those challenges. MCP is often referred to as the USB-C for AI applications. I wrote in my slide that MCP provides a standardized way for AI applications to connect to external capabilities. External capabilities here means tools or data sources. Just the way a USB-C provides a standardized, logical, and physical interface for you to connect different peripherals to your computing devices. For example, you have a MacBook here. With a USB-C, you can connect your phone, you can connect a speaker, you can connect a camera, you can connect any number of devices. As long as the manufacturers adhere to the standard of the USB-C protocol, you can connect it to any computing devices. So MCP is like that standard that if the different application developers, if they can adhere to this protocol, it will be easy for them to connect AI applications to any number of external tools. David Soryapara, one of the co-creators of MCP, he said that while he was building MCP, his thought process was he needed MCP to allow him connect his world to AI application. With the original example I gave, where you have the storyteller being boxed, a storyteller that knows so much, but there is this thing blocking it from the world. That's the same idea with LLM, where LLM has so much capabilities, but it's unable to connect to our world. So the idea behind building MCP from David Soria's perspective was to allow AI applications connect to our world. The MXN problem that I explained earlier, you have AI chatbot that is acting as a support agent. You have data analytics agent, code assistant, which can be your IDE. You have a creative writer, an LLM that has been trained to be a creative writer. Now let's say all these AI applications need to connect to a PostgreSQL or a Salesforce CRM or a GitHub API or a Google Drive. Without MCP, each of these AI applications need to have custom integrations with all of those tools. Now we have 4 AI applications here with 4 tools. That gives us 16 custom integrations. As I explained earlier, as it grows, you have more integration. That's the MXN problem that MCP came to solve. Now with MCP, it changes the MXN problem to a M plus N solution where the AI applications just need to implement MCP once, and the tools also need to implement MCP once. So let me explain it this way. Let's say the AI chatbot has implemented MCP, and the PostgreSDB, the Salesforce, the GitHub has also implemented MCP. Ignore these other guys. By so doing, we have M plus N, which is 1, 2, 3, 4, 5 integrations. Now, when you add the data analytics agent, the data analytics agent just needs to implement MCP and it will have access to the other tools. Unlike before, the data analytics agent also needs to integrate also needs to have custom integration with all of these tools. But with MCP, as long as the tools have integrated with MCP and the AI agents also support the protocol, it's like a plug and play, just the way you can plug different peripherals to your computing devices and it works out of the box. That's the advantage of MCP. This is just to further buttress the integration problem without MCP and the order that MCP brings into the picture. Now, there are components of MCP. What makes up MCP? We have the host, we have the clients, and then we have the server. The host is the application, the user-facing application, and this can be your IDE for developers. This can be either a cursor or a VS Code or anti-gravity, whatever IDE you're using. That's the host. The client, in this case, is a component within the host. It's like a small box within the host that manages communication with the MCP server. And finally, we have the server. The server is a program that exposes capabilities. Capabilities can either be tools, resources, or prompts via the MCP protocol. So, we have the client, which is a component within the AI application that connects to the server. And finally, we have the server that exposes capabilities. Capabilities in MCP. As I said, we have tools. Tools are functions that can be executed. For example, a tool could be, now all of these are capabilities within the server. A tool could be a flight, right? A function within a tool rather could be book me a flight, or it could be send airtime. It could be do a transfer. Those are functions within the tools. And tools are said to have side effects because if you do deduction there'll be a deduction in your balance, right? Tools could also be executing queries against the database. So we have tools, we have prompts. Prompts are just templates that guide users on how they can use the different capabilities. We have resources. Resources are read-only data sources that provides context to the LLM. And finally, we have sampling. Sampling allows the server to notify the client to perform certain operation, especially in an agent-to-agent integration, where you have different agents that are doing different things, and one agent tells another to do something. So these are the capabilities of MCP: the tools, resources, prompts, and sampling. Can we see this diagram? Can you see it from far? Okay. I'm just going to quickly explain the communication between these components. We had said earlier, we discussed the component of MCP. We said we have the host, we have the clients, and then we have the server. Now, how do all of these communicate? The first phase is when you start up, for example, let's say your VS Code. When you start up your VS Code, there's the initialization phase. Okay, I have here number one. So this is the initialization phase where the MCP host, which can be your ID, as I said earlier, or any AI application, reaches out to the MCP server to ask for the tools. We have said earlier that MCP servers expose tools, expose capabilities. It's basically saying, oh, I am a server, this is what I can do. You can have MCP server that manages transfer, and all it does could be to do transfer. You can have MCP server that manages support, and all it does is to support you, right? You could have different, depending on what you want. So the MCP host makes a request to the MCP server saying, what are your capabilities? What can you do? That's the first request. And the MCP server returns all the available tools. Then after that, that's, as I said, that's the initialization phase. Now we have a user that inputs data, that inputs a request, say, send airtime to so and so. Let's say the MCP server that we have is the server responsible for bill payments, airtime, data, electricity bills, all of those things. So the server has already responded that, oh, I can send airtime, I can buy data, I can help you with electricity. So the server has responded with those capabilities. Now the user then inputs send airtime to so and so. Now, the next step is that, can we remove this? Okay. Now, the MCP host sends the inputs from the user and the tools that the MCP server has exposed or has broadcasted to the MCP host to the LLM. Now the LLM has both the user request and the tools that it can use. From the user request, the MCP is then able to decide that, oh, based on this user's context, this is the tool that I need to perform the action. That is step 5, tool selection. Then after the LLM has decided on the tool that it can use to perform the action, it returns back to the MCP host. The MCP host then passes the information to the MCP client. Remember that it is the MCP client that has connection to the MCP server. The MCP host passes the information to the MCP client. Then the MCP client executes that tool on the MCP server. Then once that is done, the MCP server then returns. The MCP server then returns the result. It's at the top there, but that thing is blocking it. Do you mind moving? Okay. The MCP server then returns the tool plus the context to the LLM. And the LLM outputs the result saying, oh, I have sent the data to this person, or I've done the transfer to this person. So that's how the different components communicate. The MCP host, the MCP client, the MCP server with the LLM. Now we're going to talk about the communication protocol. How does communication happen in MCP? MCP uses JSON RPC. RPC here stands for Remote Procedural Call. It uses JSON RPC 2.0 as the message format for all communication between client and server. There are 3 types of communication between the client and the server. There is the request, there is the response, and then there is the notification. Request originates from the client to the MCP server saying, this is what I would like to do. Response is the MCP server responding to the client based on the original request. And notification is the MCP server informing the clients about the progress of whatever request that had originated. In the request, we have, this is how the request looks like. The JSON RPC field is where you define the version of the protocol, the version of the message format, which is 2.0, ID. So every request has a unique identifier. It has a method, what you want to execute on the server. It has parameters. In the parameter, you have the name, which I have here, get focus, and it takes optional arguments. Then the response also takes the JSON RPC field. It returns the ID so that you can trace the request and the response together. It returns the ID and it returns the result. Oh. All right, and the final one I mentioned is notification. That allows the MCP server to notify the client on progress, especially if it's a long-running task and the server is taking time to respond. The server can send a notification request to the client, basically telling it that, oh, this is still ongoing. This is 10% done, 20% done, 80% done, etc. Now we have the transport mechanism. How does MCP transport data under the hood? There are 2 ways MCP transport data. There is the STDIO, which is the input and output. Standard input and output, and then there is the HTTP plus SSE. SSE stands for server sent events. And streamable HTTP. STDIO is when you're testing on your local. You can build the MCP server and also have a client on your local. The communication that they would use is STDIO. But if you have an MCP server hosted on the cloud, the communication that they would use would be the HTTP. Or if you have a streamable event MCP server, it will be the streamable HTTP. Okay, using an MCP server. There are different MCP servers available, over hundreds of them. Different companies have built different MCP servers in order to extend their capabilities. I know a lot of companies that all they have is just APIs, but in the world where we have AI and LLMs, companies should go a step further to expose MCP servers so that LLMs can easily integrate with them. Not taking aside security. Definitely security needs to be in check. But what allows an LLM to be able to, for you to tell an LLM, or go to Amazon.com, buy so and so items for me, and the LLM is able to take that action, go to Amazon, pick the item that you requested for, and then process payment. That is possible because Amazon has exposed MCP servers. So if you're a business person, you're working in an organization, right? I think it's time to tell your managers that we need to expose MCP servers. Okay, using an MCP server. For the demo, I'm going to be using a weather MCP server. Pretty straightforward. Hope I was not too fast. Was I too fast? Okay, I know some of us are tired, so I have to quickly. Okay. Yes. Okay, I'm going to share my screen in a bit. What I'm saying. Okay, just 1 second. Okay, you need to disable. Seems you're still sharing. Stopped? Okay, I just want to show us a practical demo of they can't see here. Okay, so I have Cloud Desktop here. Cloud Desktop is an example of AI application. And the demo I'm going to be showing us is how to use an MCP server. Remember we had said that MCP provides AI application capabilities. It gives AI application access to do things. So I have Cloud Desktop here, and I'm going to ask Cloud Desktop, what is the weather like in a state in the US? Live demos are usually scary. How many of you agree? Huh? What was the weather like in Sacramento? Right. Okay, let's ask this. Right. So it says, so I asked it, what's the weather like in Sacramento? And the response is, I don't have real-time weather data. So let me search the current condition in Sacramento for you. So what it did is, because this AI application that has access to the web search tool. So there are different tools. By default, Claude comes with Claude comes with Figma, so you can add different tools. Now we have this web search tool. So what the AI did was, it did not have real-time data access based on its context, and it decided to use the web search tool, basically to go to the internet and get that data for us. But I like the way it responded, saying, I don't have this. Unlike previous times, it's just going to cook up something and you may think that's the correct thing. Now I'm going to include a weather MCP tool. And this weather MCP tool integration has been done to actually make API calls to weather services and get the actual weather. Let's take note of the tools that we have here. We have just Figma, we have Calendar, Gmail, Drive, Web Search. We don't have the weather tool. So I'm going to make the weather tool available so that the LLM can use this tool in its search. I'll have to close this and open it again. Right. Now I've added weather tool. Am I still sharing? You know what? I'm just going to share. Right. So now I've included a weather MCP server to boost Claude's capability. Originally, Claude did not have access to live weather data. And it told us that, oh, I don't have access to real-time data. And it was going to use the web tool to make it search. But I don't want it to just go online and get me random data. So we have a custom MCP weather server that is going to help us with the actual weather condition in Sacramento. So we have the weather MCP server here that has been added as a tool. So I'm going to turn it on. And when you click on this, you can see the tools available. It can get alert and also get forecast. Now I'm going to ask that question again. Okay, hope it works. Right. Now we see the LLM. We see the LLM leveraging the weather tool that it was provided with. And I had asked for Sacramento, and the LLM was able to realize that the weather tool requires latitude and longitude. It was able to use the web search tool to get the latitude and longitude of Sacramento and then pass it as a parameter to the weather tool. And with that, it came with a response saying, right now, overnight into Saturday, it is cool at around 40 Fahrenheit with patchy logs. So basically, it's giving us real-time data access here. And this was possible with the use of MCP. So with MCP, you can extend the capabilities of LLM, of AI applications. With MCP, you can empower AI applications. You can build solutions that will give you advantage. A lot of people interact with LLMs. Almost every one of us here interacts with one AI application or the other. Now, if you're building a solution, my advice would be not just building the APIs that existing systems will connect with. You should also make provisions for LLM to be able to interact with your solution, because that is where the future is going to. With that, I'm going to wrap up. Thank you. Are there any questions? Any questions? Okay. It means everyone understood. Okay, please.
Yeah, sorry. Thank you. So I just want to ask, like, how that server you had it, like, is it something you already hosted? Like, how are you able to add it? And another thing, you said once you called an NCP server, right, it's meant to execute a function. So is it that server, is that you have categories of function embedded in it, or was like, I don't really get.
Yes, thank you. Thank you for that questions. Okay, that's really bad. Right, so I was going to show us how to build MCP server, but because of our time, we can't do that. So this is the MCP, this is the weather MCP server. And the display is really poor here. We have, this is the code base, we have the primitive. I don't think it's zooming in. Right, okay. So we have the prompts. I mentioned this earlier. We have prompts, resources, and tools. Now under tools, we have the get alert and the get forecast. Now in the get alert, just 1 second. Right. I'd registered the tool. I created a tool, and I'd said the tool name is get alerts. And what this tool does is it gets weather alerts for a state. I've also registered a tool called get forecast. What it does is to get weather forecast for a location. You could also create a tool, and within the tool, you can have different functions. It could be query a Postgres database. It could be find out what the issue is with this transaction. It could be whatever it is. It could be to book a flight, whatever action that you want an LLM to be able to perform. That's what tools are. Now, we have the input schema here, which is the latitude and the longitude. So when in the diagram I showed us earlier regarding communication between components, the MCP host connects with the MCP server. The MCP server responds with its capabilities. And the capabilities of this server, as we see here, there's the weather server. The capability of this server is to get forecast and get alert. That is what the server can do. And that is the same thing that we have defined here. Get forecast and get alert. Now, when LLM sees that you want to get something about weather, in the diagram I showed us, after the MCP server returns its capability, the MCP host then passes the user input and the tools available to the LLM. The LLM is then able to say, oh, based on the user's request, based on the user's context, and based on the tools that I have, this is the appropriate tool that can satisfy this query. Now, with the question that we asked Claude, saying, what's the weather like in Sacramento? Claude was able to look at the list of tools that it has access to, and it was able to decide and determine and say, okay, based on all these tools, this is the most appropriate to satisfy this query. And because of that, it was able to execute the tool on the MCP server. Do you understand? So there is an MCP server which is hosted locally here. And the way you add it to Claude, this is where the configuration is. You can add one or more MCP servers to Claude. This is Claude config here. You can also do the same thing. VS Code has the same thing. You know, all AI applications have a way for you to add MCP servers to them. Does that answer your question? Okay. Any other question?
We will take the questions later. And maybe
Thank you very much.
Sorry, because of our time. We still have one final session. And we'll be out here in just about 20 minutes. We'll be out of this place. And we want to say thank you for staying with us this far. And like I said, in 20 minutes, we'll be out of here as we take the final session. The final session is building AI agents. And please help me welcome the convener of Dev Community Mentorship, Samuel Olabamiji. Please, let's give him a round of applause, please.
Hi, everyone. Good evening. Yeah, I know we'll be very tired by now, so I'm not going to take our time. I'm just going to summarize my talk. I'll somehow make the slide available when we're done for us to kind of go through it. So I'll be talking here about building AI agent, the principles, the patterns, the tools. My name is Samuel Olabamiji. I'm a senior platform engineer at League. And what does platform people do? We build tools that other developers are using to build their own tools. And one of the tools we worked on this year was an MCP framework that devs can use to build their MCP services to connect to AI agents. So what's really an AI agent? I'm going to simplify this so that we are going to be able to conceptualize what I'm about to say and make it easy for us. An agent, so to speak, but before we get to that, AI as it is, artificial intelligence, is man's attempt to create machines that behave like human beings. Do you agree with me? So that means everything you are seeing with AI is what? Making machines that behave like human beings. And we are getting closer to it. It might take some time. Now we have things like object detections, character recognition, and things like that. The intelligence of computers before used to be numbers. Computers are good with 1 + 1, 2 + 2, and things like that. But when it comes to things like perception, do you recognize the person beside you? Yes. Do you get a computer to recognize the person beside you? No. So what artificial intelligence is doing is what? Bridging that gap. Bridging that gap. An AI agent is also what? An effort to make that closer. Am I communicating? So what's an agent? An agent is anything that can perceive its environment and act upon that environment. An agent is anything that can perceive its environment and act upon that environment. When we sum it up, that means agent is able to what? To interact with his environment through senses. So what we're going to be doing now is that I want you to put yourself in the shoe of an AI agent that we're going to walk our way through it. Is it clear? So as a human being, you have your 5 senses. You are able to interact with your environment. You are able to see, you are able to smell and all the rest. Then you are able to make decisions. So that, for instance, if I tell you to stand up to go outside, what will you do first? You want to look. Then when you look, you are going to chart your path forward and take that walk and go outside. So that's what an agent is also built to do. So when we're talking about this, you want to start visualizing machines like Tesla. I don't know if you've entered a self-driving car before. What does it do? It's able to look at the road as its environment. It's able to use LiDAR sensors and camera to see the road. Then it has its map to chart its course to a destination. Is that very clear? So any machine that can interact with an environment, with its environment and do what? Take decisions based on that, it's an agent. And why am I defining this to you is because we already have the concept of agent before we had AI agents. So that means AI agents is not the first agent that you would have. Maybe in the 1980s, on things like that, we've had agents. If you play PS, the computer will play with you, right? That's an agent. Because he's able to see the field, he's able to play in its environment. That's an agent. Anything that is able to perceive the environment, it's an agent. But an AI agent is an intelligent system that can operate independently of to accomplish a specific goal by perceiving its environment and take action. Agents can observe the environment, reason about what needs to be done, and act upon it in a continuous manner. This happens iteratively until it achieves its goal. This definition contains everything that you need to understand what an AI agent is. It can observe the environment, it can reason about what needs to be done, and act upon it in a continuous manner. This happens iteratively. For instance, if you code with cursor and the rest, you are going to supply with your code base or things like that. That's an input into what? Into the environment. That means your ID is the environment in which what cursor is acting on. Is it clear? So when you have that environment, it's able to observe it, it's able to reason about what needs to be done. So you can say just write an API response endpoint for me of this and that and things like that. It's able to reason to it. It has a goal. There's always a goal. The goal of a Tesla is to what? To get from one point to another. Every agent has a goal. And what makes agents what they are is that they are able to reason until they get to the end of that goal. They are very goal-oriented. Characteristics of an agent, you have intelligence, which means it's able to reason, is able to learn, is able to adapt. The second characteristic is the perception. That means when you see, you have senses. Senses means they are feeding you with information. Perception means you are able to interact or interpret what you are getting through your senses. Is it clear? That means your eyes can see, but it's your brain that can interpret what you see. So the combination of those two organs is what we call perception. Then we have the third one, we have the autonomy, which means being able to make decisions when an human being is not there. And that's what makes an agent different. Some authors we call autonomy for you like agency. And autonomy is like a degree of agency. So what it does here is Tesla is able to drive you without you holding the steering. That's autonomy. Being able to make that decision and get you to where you are going. That's autonomy. Then the fourth one is action, being able to perform action. And the last one is goal-oriented, performing sequences of actions until a desired goal is met. I put up a component of an agent here. So you have your environment here with you, and you have your inputs, you have your perception, you have your memory and knowledge base, you have your learning, your decision-making, then you have your output. Perception is the way an AI agent can interact, understand what you are feeding into it. Then memory, what? When you talk to someone, you remember, right? Then that means an agent also needs to have a memory. What memory does for you, if you say, how big is the sun? And then you chat again and you say, what is its size? That means the AI agent needs to remember that it is a pronoun and it's referencing an object called sun. So memory is the way what an AI agent is able to keep track of conversation. What ChatGPT is actually doing for you is it's managing memory for you. If you ask LLM 2 questions, normally it's not supposed to be able to link in together. But ChatGPT has been built on top of LLM. Is it very clear? So that means there's a difference between ChatGPT and open AI. ChatGPT is a chat interface, while OpenAI is a type of large language model. So you have your what? You have your memory, you have your decision making and planning. If Tesla is going to walk from here to here, it needs to plan. It checks the map and say, how does it take? I mean, how long does it take me? Decision making means you want to go to maybe somewhere like Ojota from here. You can go like this or go like this. You need to check the traffic. That means if you're writing an agent that will get you from one place to another, it's able to make decisions and compare, okay, how do I get you faster to where you are going? That's what it does. It makes decisions. It's also learned. He's able to learn. If he makes a mistake, he's able to incorporate the mistakes into his flow. Then he's making to take action. That means after knowing where to go, that action is, let me move forward in this direction. Is that very clear? So we move forward again to the next stage, the large language model, which is one of the components of an LLM. The large language model is what everybody is used to, the OpenAI, the Claude, the Gemini, and the local ones and all the rest. They are like what? The cognitive engine of an AI agent. And what it does is it reasons and makes decisions. It does natural language understanding and generation. So when you talk to an agent, like your code, you talk to it in English. How does a computer understand English? Because computers don't speak English. That's what we call NLP, natural language processing. So what it basically does is what? To take your character, we are going to get there in a bit, and being able to interpret it. So the component of an agent that does that is what? The LLM. So LLM is a part of an agent system. Then you have what? The task decomposition and planning that we have spoken about. Then last, we have tool selection and orchestration. I think Kayodeji mentioned how tools work. So LLM does what? It chooses tools to you. We're still going to talk about tools briefly in the context of an agent. Then I call this the edification of a large language model. How many of you watched Coming to America? Or you know who Eddie Murphy is? What's the unique thing about him? He's able to take multiple roles, right? Then he acts like a grandma, acts like this and things like that. That means LLM is also an actor. And you are the script writer, you are the one to tell LLM what to do and the roles to take. So for instance, you can tell LLM, you are a helpful travel assistant. Always give helpful travel advice. So that means I want to build an AI agent that plans travel for people. One of the things you are going to do is to what we call give him a system role. So LLM has a concept of role, and we have 3 basic roles, more than 3, but majorly there are 3 for most of these LLM. We have the system roles. System roles is where you set the goals, the constraints, and the behavior of the model. What I'm trying to do now is to get you to a place where you could pick up any agentic tool and be able to understand all these components. Exactly. So we have the what? The system role. The system role is where you give an LLM a role of how to act. So now I want to build a travel planner. So I tell it, you are a helpful travel assistant. Always give travel advice. So now the next role is what? The user role. So that means you are the dev. You are the one giving the system role. Our agent. So I want you to, when is the best time to visit Bali? This is a very important question. If you happen to travel to places where you don't know their temperature, you'll be shocked. Then when is the best time to visit Bali? You say visit Bali during the shoulder months, April to May or September or October, for the best combination of good weather and all the rest. Now, what we have here is the system where you give it a route of how to act. What you have here is the user. When user acts, you ask your agent some questions. And what you have here is what? The model responding to you. Is it very clear? So the model will tell you this is the best time to visit Bali. If you have ChatGPT with you, ask this question. If you don't tell ChatGPT to act like a travel assistant, it might be telling you some nonsense. So that means role is the way you condition the mind of an LLM for what? For what to do with its time. Is it very clear? Okay, so let's continue because of time. The first one I said about the component is the LLM, right? So the next one is tool calling. Tool calling is the way an LLM interacts with its environment. An LLM cannot perform actions on its own. Is it very clear? For instance, if you are there, if you open Claude or OpenAI, okay, say, what did Arsenal play yesterday? Claude or OpenAI will not know it. But we tell you he knows it, he's going to hallucinate. But people like Claude will tell you, Arsenal plays so. I can tell you. There's a setting inside Claude. He has a tool called web search. So what happens is, whenever you give an LLM a task that he doesn't have, it checks for tools. I think it was explained earlier that he could use to perform its action. So tools are what? Helps an agent to act on its environment. For tools, you are able to get information from the outside. You are able to get information out. So for a Tesla, what is the tool? It has a sensor to read the road. That's a tool. Then it's also able to move. I would explain tools more in the example we're looking at, but just know that tools is just the way an agent is able to what? Perform actions. So next one is the memory. We have 2 kinds of memory. We have a short-term memory and the long-term memory. I think this morning some of our speakers have spoken about the concept of agent context. Agent context is what? All the information that an agent has access to. An agent in this way is an LLM, because LLM is the one that deals with memory. And I said, if I say, where are you from? And I say, I am from Lagos. What is your place of origin? My place of origin is Lagos. So if I say, what is the temperature in your place of origin? How does the LLM know that the place of origin is Lagos? It's through memory. So what it does is that for devs that are here, you create an array of your conversations. Like I showed you the role. Whenever you make a call to an API, you keep appending that array. That's how you manage LLM conversations. Then the next one is a long-term memory. Long-term memory means that how will an agent understand your preference over time? So for instance, you are chatting with a banking assistant. Oh, I want to open let's say child care assistant. I want you to deliver food for me. Then you are saying, what's your preferred method of payment? You say card. And I want you to remember this. When you end that chat, short-term memory cannot remember. You have to store it in a long-term memory, because next time what would happen? An agent that have forgotten is like you have forgotten your wife's birthday or your wedding anniversary. That's how your agents will look like when you don't have a long-term memory. So what you do is you are able to do what? Store in the persistent database like Postgres, Mongo, and the rest. So your agent is able to do what? Is able to remember long conversations. That's different between short-term and long-term. Short-term is, I'm talking to you now, then I went out. And when next I'm talking to you, everything we spoke about in the short term is gone unless you save it. Is it very clear? Then you have a long term memory. We're really running out of time. I need to speed up here. Then we have knowledge. There's a difference between memory and knowledge when it comes to agent. Some authors will tell you they are the same, but they are different. Memory is what? Your information you have from interacting with people. That means if I'm talking to you, what's your name and things like that is a memory. Knowledge means I have this information, but I didn't get it from interacting with people. So everything an AI agent is going to answer comes from knowledge. Don't forget that what we call an LLM is a model that was trained with a lot of information. So that information is called knowledge. Now, that is training knowledge. But if you understand LLM, you know that LLM has training cutoff. That means if your LLM will be sincere, if you ask your ChatGPT, when was the last time you were trained? The version of ChatGPT will tell you, I shouldn't have an information that is beyond this date because that was when my training ended. That's what training knowledge. Training knowledge is limited. That means if you ask a ChatGPT that what was the score of Arsenal's last game? Don't worry, I used to be an Arsenal fan. That's why I'm using Arsenal. And they are winning. I used to be. Then what was the score of your last game? You say, understand. LLM will understand that this requires external knowledge. That means he's not able to tell you the score of the last game. He's going to use a tool to get it, or use something called RAG to get it. I think RAG was explained earlier. So I'm going to skip RAG. So he makes a request to a website tool or generate an answer for the user. And he incorporates and tell you, Arsenal won its last game. They beat Everton. Was Everton they flogged 4-0? I've forgotten. They won 4-0. So that's how LLM will tell you. So the only way LLM would have access to information outside its training knowledge is what? Is through use of tools or something called RAG. And RAG is what's retrieved augmented generation. So sorry, I would not be able to explain RAG because of our time. But what RAG does is to do what? To basically augment your prompt. So let me just go through this. You are a customer service agent and you have some data that you want your agent to have. You want your model to have. What you do is RAG. What RAG does is you take all those documents, you ingest it to what called embedding model. You can Google about embedding models. They are tiny, tiny model. What they do is to take text documents, they convert them to zeros and one called vectors. If a machine learning person here, you have heard about tensor, vectors, and things like that. Vectors are just zeros and one. So it converts it to vector. Then when a user is asking question, what does it do? It checks the RAG and does what? Does it match what I have? I can't really explain well due to time, but you could read a bit on RAG, vectors, semantic search, vector databases, embeddings, and things like that. But what we call embeddings is just the process by which a text is converted to numbers. That means your OpenAI, your ChatGPT doesn't understand text. It understands what we call embeddings, zeros and one. And the way it works is it converts it and it looks for the nearest or the closest numbers and use it to return response to you. That's what it does. That's what ChatGPT does. It doesn't understand everything it's telling you. It only understands zeros and one. Yeah, it doesn't. So there's something called vector space. And you have that vector space, you have a lot of dot. If these two are closer, ChatGPT thinks that they are related. But if they are far away, they are different. So if they tell you male, there are two kinds of gender, complete is male. Inside this thing, female will be closer to male. That's semantics. It stores information based on their meaning and relationship. Love and hate, depending on which it can be far apart and it can be closer. So that means semantics means what? The meaning of a word is very clear. So let's just move a bit to save time. So another thing we've talked about LLM, we've talked about tool, the memory and knowledge. Another one is what we call the agent control logic. How do we tie everything together to make an agent work? Is what I call the long control logic. It's just a tool. It's just a loop. It's just a loop. I built an agent from scratch and the control logic is just running a for loop. That's just what is inside an agent control logic. What does it do? You set a prompt to it, then it sends the prompts to a model. And from the model returns the response back to your control logic. The model will tell you to call a tool. And when you call the tool, your control logic is the one calling the tool. Model does not call tools. All this get weather and everything, you learned it from MCP. Models don't call through tool. So it's always a loop that happens. It calls a model, it calls tools until it reaches its goal. It's more complicated than this, but I'm just going to give you something. So let's quickly have a quick example, and I think we'd have to end there. I still have like 15 slides, but we may not be able to cover that. So let's just have an example. I want to create an agent to summarize important emails. We get a lot of emails, but I want to create an agent to summarize important emails and send me only the important ones. As a human being, what will you do? You open your inbox, you look through your email, you start clicking. Once you see email from HR, you know it's important. Once you see email like salary increase, you know it's important. There's some email from the sites that you are registered with, they are not important. Why not we do create an agent to do that? So the first thing is you write a prompt. I said system prompt is a prompt you use to instruct an agent. You are an email assistant agent with these tools. So when you write a prompt for an AI, one of the things you do is to let the AI know the tools he has access to so that I can make decisions with it. Is it very clear? So now you have the tools. I have a tool called read emails. How do you have access to my email? I'm going to create a tool, maybe using MCP for you to read my emails. Then I have another tool called send emails. So you're going to read my mails. What you're going to do is that you're going to analyze my emails, identify the important ones, and send the summary. So what's going to do here is what? How do I identify the important emails? So I said you should think like an AI agent would think. Is that clear? So if you tell an agent identify important emails, you need to let him know what is really important to you. So that means if I'm talking to you and I tell you, open an email and let me know the emails that are important, what would I ask you? What is your criteria for identifying? So that means if you talk to an LLM, you have to position yourself as if you are talking to a human being. So one way to craft prompt that works is to ask yourself, if I'm being asked this question that I'm asking the LLM, do I have enough information to prosecute the action? Is that very clear? Analyze this. So important emails would have action required or time-sensitive content. So LLM is intelligence. It cannot time-sensitive content. If an email contains otherwise last, you know it's time-sensitive. Or if an email contains Black Friday, 99% off, even though most of the Black Friday is scam, but we are taking them like that. 99% off, you know it's time-sensitive, it's urgent. Then it's going to do what? Going to record it as important from supervisors or clients. You can add urgent keyword. So the user prompt is like, analyze my emails and send me a summary of the important ones. What the LLM is going to do is what? Use this tool because I have a tool to read an email. You go and read your email. Then we execute all these to plan what are really, really important. Then after that, it's going to send an email to you. So it has two tools, one to read emails, one to send emails. Don't forget that an LLM cannot perform actions without using tools. So that means you have to create tools that it's going to use for you, then it's going to send the email. This is what we have here. You have the system prompt, which is what we have here. You tell the agent his roles and the capabilities and available tools. You let him know the instruments you have given to it. Then how do you decide to perform your goal? Then the LLM is the brain, reasoning and decision making. The LLM knows the tools to select, whether it's read email or send email. LLM does not execute tools, you only select tools for your own code to execute. Is it clear? What OpenAI and everybody is doing that they have tools, it's not LLM that's executing the tools, it's their own system. Is it clear? So then you have the tools, read email, send email, then it's able to perform that action. We have things like design patterns, when to use design patterns. I'm going to be sharing this slide. We have multi-agent systems because you may need to use multiple agents to perform your actions. We have frameworks you can use for building agents. So I want you to I think I've pressed something here. I want you to just rehearse those, check those agents, those tools out. We have the LangChain, so you could take LangChain, you could use Creo AI. Most of them are Python friendly. AutoGen is from Microsoft. for building AI agents. Google has an ADK. Almost all major vendors have their own agentic tools. Open AI agent SDK, Cloud Agent SDK, depending on what you are using or what your company is using, you are able to just experiment with some of these things. All of them have their opinionated on how they solve their problem, but everything we spoke about here, memory, knowledge, tools, everything holds true. They are concepts for building an AI agent. Then if you want to read more, I think I have one guide by OpenAI, 25 pages on building AI agents. Very straightforward and simple. You can start with this. Then building effective AI agents was written by Claude Atropic. Then you have agent reasoning patterns. How do you allow agent think through what it thinks, what it's doing? We have two major types of reasoning pattern. You have the react and observe. Then you have the planner execution. React and observe means that when you give an agent some work to do, it quickly thinks about it and start working on it. Then it thinks again and it works. It thinks again and it works. Planner execution means that it will plan everything, then execute it later. Everything I said to you, they are prompts. You can write prompt to act as react and observe. Everything called design patterns in agents, they are prompts and to calling. I will not be able to take question because of time, but if you have question, you can shoot me question here. I hope I was able to introduce agent to you in a manner that's simple.
Was quite impactful. And we'd like to say thank you very much to everyone. And that gradually brings us to the end of today's session. Please, can we give all the facilitators and all the keynote speakers and all the panelists, every session, the food, the break. Please, let's give them a big round of applause. I'm very sure it was indeed worth the time. It was indeed worth everything. So right now we will be going out for photographs. And I think that will be the end of today's program. So on behalf of Dev Mentorship Community, I'd like to say thank you for coming. And next time when we call on you, we hope you will also be here to join us. I also want to say thank you to all our partners, everyone who supported in one way or the other to make this event a reality. We say thank you very much to all of you. All right, so till next time, see you later. Peace out. Thank you. So let's go out for photographs, please. Everybody, pictures outside.